Hey, hello everybody. How's it going? Welcome. Compiler work. Make this announcement so we officially go live. I am tired this morning, but we are going on anyway. Make it compiler part 14. Sorry about that. A little bit of a cough. Alrighty, we are officially live. I was working on my text editor last night, so I have Emacs open. Might as well check that out. I implemented very simple cut, copy, and paste operations. So you can now cut and paste as much as you'd like. Ain't that wonderful? Alrighty. It's not integrated with the system OS yet. I still have to make the optional link with libclipboard done, but it's not bad. Sorry about that black flash if you did have one. And I think I just have to head over to the fun compiler. And sure, math is okay. Let's go to todo.org. All right, I'd say we're nearly done with these last two. But we're going to be working on them forever, so, you know. Yeah, we fixed that. So, effectively, I should kill a bunch of buffers in Emacs. But while I'm doing that, let's think about what we need to do today. So today we are going to be working on the compiler, as I said, but we're going to be working on scope and codegen symbol resolvation. What is that called? Codegen symbol solution? I don't know. Just turning a symbol into what it needs to be, effectively. Yes. Hopefully that made sense and wasn't, like, ridiculous. In any sense, we will be... Don't need completions or disabled command. What is it? X. No. D. Yes. There we go. Clean up my Emacs a little bit. Help us out. So the issue right now is that... Also, welcome everybody. How's it going? I forgot to ask. How are you? We'll give a welcome. Put it in like fancy... Yeah, that looks fancy, right? ASCII art. Woo. Okay, so what we're going to be working on is scope resolution, and the problem is the parser currently gives a parsing context, which is effectively our scope, right? And the problem is that this scope kind of just returns the global scope. There's only one scope. And the issue is that we don't store our children's scope. While we're parsing, we discard them as we go. We kind of just ignore them, which is not ideal, right? It's kind of a big issue, actually. So for example, if we defined, let's look at our simple example. Where is that? Okay. Here. So here we have A and B. A is defined as an integer, and B is defined as an integer. So we would have A, which is an integer, and it would be in this global scope. And then we would have B, which is an integer. And these would be symbols, and these would be ints. And they'd have some value, right? Possibly. The B would have 0. So this is fine and dandy. Our current scope resolution works. as far as the global scope goes. But the issue becomes when we define a function in this old syntax, I should say. And oh, good afternoon, Eternal Wild Fox. How's it going? How are you? I saw your PHP object-oriented programming is going along very nicely. But the problem becomes either here or here. Eternal Wild Fox says, it is going well. What about you? For me, it is morning. I just woke up, so it's kind of not going yet. But I've just, I found that article I linked in the Discord, and it's, I think it'll help me a lot in figuring out how the symbol table. Eternal Wild Fox says, question about OS dev. How did you start, Alal? If you go to my GitHub in Lenser OS, I think there's a link to the tutorial I used originally? Question mark? I may have removed it at some point because I stopped following that tutorial. Yeah, so let me go back to like, I know I'm on my second screen right now, but it's temporary. Go back like 400 commits and see if it's in here. Yeah. So if you go here, I'm going to link it in chat, alrighty? That's a link to Lenser OS in the acknowledgements section of the README. And here, I can do this too. So that you'll end up here. And in the acknowledgements, I have a bunch of places that helped me get started. So yeah, Poncho's GitHub was like the first one I followed. So these two. And he's actually where I stole my original GNU EFI libraries from. This whole thing. And then I built my own bootloader, but I'm still working on transitioning to it. If that makes sense. Because EFI is really easy, you just need to make bindings. It's not too hard. But yeah, so I followed this Absurd Poncho guy at first, but he really doesn't have a lot happening here in the end. You can see this is the final kernel, and like he has a pit for scheduling. He doesn't really go into multiprocessing. He doesn't really go into kernel design at all. He just gets you to a place where you can actually print a font to the screen and then says, all right, have fun. See simple fonts and everything like that. And gets you through the interrupts and like all the hardware basics. His AHCI code is terrible, and I wish I didn't follow this tutorial for AHCI, but at least I got it done. You know what I mean? At least I got it done. AHCI, there's just a lot to do underneath the surface. But yeah, so this is not a bad one. Make sure you check out the branches in Poncho OS. And YouTube OS is like his first one, where he does it from assembly, and he gets you, I think, from 16-bit to 64. Yeah. There's some things, right? So this is the 512-byte bootloader. There's a lot. But yeah, these all helped me a lot decide what kind of OS I wanted to work on and how. But after I didn't fork it, I just wrote all the code from scratch following he has a YouTube series on it, I think. Yeah, he doesn't link to it, but it's on YouTube if you look up Absurd Poncho. But yeah, hopefully that helps you out, Eternal Wild Fox. That's where I started. Alright, train was coming by. We took too long. So the idea is that we either have to store scopes as a node, right? Because if a scope is a node, then we could just look up in the scope another scope. But if a scope isn't a node, like in the environment or whatever, then we'd have to have like a list of children. This would be like children, right? And then we'd have to like contain children, and each of these would have to have some like scope ID that we'd have to look up so that we can actually traverse the tree, or we'd have to traverse the tree in order. Eternal Wild Fox says, yeah, I think so, I hope so. But yeah, that dives deep into into like writing C and C++, right? And compiling, and he uses a make file, which I don't like. I converted it to CMake myself. I just switched the build system so that I could generate a make file that works and not have to write in that awful language called make. So we'd have to have some sort of scope ID to look up scope or have them in order. To be honest, my C++ knowledge is basic. Well, that's kind of perfect, to be honest. Mine was too. You don't need to be able to know how to use the standard library because you don't have a standard library when you're writing a kernel. So if you write in C or C++, it's like you don't have a standard library even, so you're just writing code. You know what I mean? Like basic code with structures, and there's no actually like linking or anything like that because you're just writing a freestanding program, a kernel. It's like the one program that controls the hardware. So you don't actually have to include anything, but it also means you don't get things like strings. So in C++, you don't have strings, you just have, you know, char pointers, like in C. You can write your own string class, but you're going to have to write your own string class for the kernel, and then you have to make sure it's memory safe, because it's the kernel. So it's a lot of just basics, which is the good part. Nothing is too complicated, it's just a lot of non-complicated things all at once. Memory safety is important. It's not important, it's just it needs to be somewhat correct. You know what I mean? Because like if you're overwriting 1 byte past the end of your heap allocation, it's not the end of the world. The heap is meant to be written from. You know what I mean? It's probably not going to crash things, especially if you write everything in the right way. Whereas if you like in the kernel end up with like you put a string in the wrong place, not on the heap, that would be a big problem because the kernel has access to all of the system memory. So you could overwrite like literally the code that's currently executing, you can overwrite it with the code that executes. And then you can change the instructions that are happening next, right? It's crazy. So the kernel has so much control over the hardware that you have to make sure you don't end up messing things up. Because if you write to low memory, that's actually hardware mapped memory. And on hardware, you can actually wipe the BIOS, which is not ideal. So you just got to make sure in your kernel that you're being a good boy with your pointers. Eternal Wild Fox is lol. But that's why we have virtual machines, where it doesn't matter. And you go, oh, it just keeps restarting. Weird. Close. Go fix your bug. Not like, well, my computer's toast now. So, do we want to be able to reorder functions? Is that a thing we would like to do? I don't know. I don't think we would like to do that during compilation. I don't think any reordering needs to happen. So the idea, if no reordering happens, is that scopes are stored in this list in order, which would mean that we end up with like, what would we end up with? We would have like scope 0, and then this would contain, again, the scope. Well, this would contain C, which is an integer, and B, which is an integer. And the reason we need this is when type checking, we need to get these symbols types. But if we name, for example, this A, we want the local declaration to override, kind of, not override, but shadow. We want the local definition to shadow the global declaration. So to do that, that would mean that we have to keep track of which scope we are in and search bottom up. We can't search parent down. I would love to search parent down with the scope ID and have everything relocatable, but not yet apparently, because keeping things in order will allow us to, keep things in order. I don't think that's too complicated. Eternal Wild Fox says the visitor patterns worked out pretty well yesterday. Yes, that was so cool. I read it later in the day after I had some food, and I was like, I get it. I get it now. Not sure how to do it in C++ or C, though. Yeah, the way you did it was definitely not doable in C, because I don't think you can call a string as a function name, if that makes sense, because I believe that's what you were doing. So you would have to do it in a way where you just use an enum. Here. So this is literally how we do our nodes. So we have an enum here, which is just like a number assigned to a symbol, right? We have some symbol assigned to some number. Then we can just use this symbol and it'll equate to this number, this integer. But it's typed, so you get type-checked symbols effectively, right? So we have this enum, which is a type, and then we have a structure which has this type as a member. And then in your transpile function, is that what you called it? You had transpile? So you transpile a node or something? Is this how this works? So you'd have to transpile a node, and then you would say switch on node type, right? And then you could just handle the different cases, like node type none. And then do stuff here for none, right? Stuff like that. So then in your case, it would be number. And what was the other one? Binary node. Eternal Wild Fox says, yeah, I get it. Awesome. But yeah, that's how you do the visitor pattern. And that's effectively exactly what we do. It's just we don't have this as a... you can't really have objects in C, right? So you could make a structure that's like transpiler or something. And you could have technically like a function pointer. I think this is how you would do that. So you could have a function pointer that's like transpile. And then you could have different transpilers that deals with the different things. Or you could just have this function act as your transpiler object and not worry about the object-oriented stuff, because this is the same thing. It's just in C. I'm glad you get it, though. That's really cool. It's all doable. It just requires a little bit of refactoring. So, if we keep scopes in order, we can just go in order. And when we find a new scope, we can just say, okay, if it's like a scope that is within, and the scope hasn't ended, then find the next child scope. Or if the scope ends, go up and then get to the next child. That doesn't sound that insane. That doesn't sound that insane. So, I don't know about you, but this seems a lot like a node structure. So maybe we should try and stuff our environment into a node. How does that sound? So, an environment, truthfully, we never use the parent thing because we store environments in the scopes, not the other way around. I guess we could just use a node and have like an associative list. Eternal Wild Fox says, that sound pretty okay. Yeah, it's C isn't more complicated, it's just lower level. You have to think on a lower level, like, okay, what's the hardware doing? What is the stack? Why can't I recurse 1,000 times? You know what I mean? It's like, oh, because the stack grows. that's a hardware problem. That's not fixable unless you change the hardware, which people are working on, but it's going to take a while. Alrighty, so we have a lot to do. We have a lot to do. What if we start with, instead of starting on the scopes, let's just get our code Rust off, not in Rust, just get the scale off and see if we can't type check a binary operator. Right? Hey, LandarXT, how's it going? He says, I have no funny introductions, which is a funny introduction. So you succeeded. Effectively, so to type check a binary operator, we're just going to have to ensure that the expression we are given, it will have two children, which is a left-hand side and a right-hand side. And this binary operator will have information stored in the top level context. So I'm just going to say, we don't really have a context iterator. We're just going to use context directly, like we do elsewhere. Doesn't really allow for continuations, but we shouldn't need continuations while type checking. Hopefully. Okay, so the idea is that we get to the top level context so that we can look up in this environment and we would like to get what? Node ID. So this binary operator, didn't we have get by symbol? Is that what I saw? So can we use expression value symbol? And then Eternal Wild Fox says, ha ha ha, that was funny enough. That's right. He came in with a joke and said it wasn't a joke. Meta Man. It's good to see you, LandarXT. How are you doing? I'm glad you are tuning in to our epic compiler work. So while context, environment get symbol. So we get the binary operator into value. So can we print this out and see what happens? Oh, I did not. Yes. Hey, I think that's right. Yes. Yes. We get a warning that string compare has an implicit declaration in CodeGen, so we need to include string in CodeGen. LandRXT says there needs to be some sort of bar for what counts as epic compiler work. Should we set up an international diplomatic summit to define it? Lamau. I don't know, should we? That sounds like a lot of work. I think all compiler work is epic, in my mind. Unless you're just like copy and pasting someone else's code and not understanding what you're doing. So this now crashes, which is very interesting. Because we're dereferencing a null pointer here. I always forget that. That's better. And look, we have a plus. And that's it. Pretty good. So when we type check a binary operator, we should say what? We should basically, this is going to be a recursive type checking type of thing, because a binary operator may have a binary operator as a child, right? So or any type of operator, really. So we're going to have to call expression return type on its left-hand side and right-hand side. So let's do that, right? Expression return type on left-hand side and right-hand side. Whoa, that got jittery. That was crazy. I don't know what happened there. How is everybody doing? We are working on our compiler, on our type checker. I'd like to get the return type. See, I'm worried about context being mutilated here. Mutilated. Somehow. I gotta be better. Root. Yeah, let's do original context. Why not? Did you hate it when you mutilate a variable? LandoXT says, I'm doing how, what, banana and tomato? Lamau. So, expression children should be the left-hand side. So I would like to make sure that if the left-hand side return type does not equal so this value children is precedence. If we take a look at compilation, value is this none here. So precedence and then next child would be return type, I hope. So this is our return type, and we need that type. I should say like if type doesn't equal, but we're just gonna do this for now. This is a little confusing. So, and the problem is we should, oh. Okay. So if the return type of the left-hand side expression in this original context does not equal the return type, yeah, that's not right. So I need the left-hand side return type. There we go. Because if we look at parser.h and binary operator symbol in the context, no? Yeah, here it is. So the left-hand side return type would be none, children, next child, next child. Yes, children, next child, next child. Perfect. Eternal Wild Fox says, I'm considering making a library repo with an abstract lexer and parser class, which I can reuse. That would have been a great idea somehow. Not sure yet how to link it in other projects. Yeah, it would definitely work. I mean, honestly, you could make like the simple lexer, like just a white space lexer, very, very efficiently. But if you kind of write it like how our lexer is written, you could probably get away with just having these be like part of your creation of your object, right? So say, okay, what are the comment delimiters? What's the white space? What's the delimiters? And then you could just tokenize it like that. So you could build your lexer probably pretty simply, and it wouldn't be too difficult. But the parser would be way more complicated to abstract. That would be like pretty impressive. You'd be writing your own parser grammar, right? Your EBNF, basically. Is it ENBF or EBNF? I always forget. So this should return error because there's a type checking error. Left-hand side of binary operator does not match. So return type of left-hand side expression of binary operator does not match declared return type. Left-hand side return type. That's maybe the worst error message possible. And we're just gonna print we'll print expression, because that'll print the binary operator and everything. Return type of left-hand side expression of binary operator does not match declared left-hand side return type. Not the best error message, but it is accurate. So we're now erroring because plus has a left-hand side of binary operator, and we haven't actually fixed expression return type to handle a binary operator. So the return type of a binary operator should be, oh man, so we're gonna have to effectively, this is a binary operator. What do we have to do? See, it has to be handled differently, because if it's a binary operator, we would like to type check it as well. Type check this operator as well. I don't know if that's the best or if that should be done here, but we're going to be needing to do it. So, for at least this pattern to work. And at least move this onto its own line. Not be so horrible. Okay, then we're going to have another child. Spitting them out. And we're going to check the right-hand side. Not the best error message once again, but it's fine. LandRXT says, don't move anything onto its own line. Make one line of code. Why? Why would I do that? That doesn't make sense. Then you make the text editor deal with it, so people see it differently in different text editors. So it's like, it's not the best. This makes it readable on pretty much every text editor. You know what I mean? Like, I can make this text gigantic. I can make it small. It still works. With these long lines, I tend to break them so that I don't have to deal with the wrapping of text, because this is not, I hate it. LanderXT says, real estate prices are getting higher. Mr. Mugume says, saves new lines, thus file size. Does this truly matter to you? Do you even look at how big your files are? It doesn't matter. They could be a megabyte each. It's not like it affects us. We can still write code the same. You know what I mean? None of that actually changes things. It's just the amount of white space in between. If the language ignores white space, why not make it pretty? You know what I mean? In any case, Christ, this is ugly. I gotta fix it. But we check the next child with the right-hand side return type and say, right-hand side does not work. We're still gonna get the same error. Nope, we get a big problem. Interesting. What is our big problem? So expression. Also, how's it going, Mr. Mugume? Thanks for your first chat today. Thank you for tuning in this compiler work. Rohan says, good evening. How are things going so far? Not bad. You know, we're getting there. We're not the best at programming, but we will get there in the end. Okay, this is starting to bother me. I gotta do it. I gotta zoom in. I'm too blind to work like that. Then I'm gonna have to do this and this. Perfect. Mr. Mugume says, I'm half lurking like always. Aw, we love lurkers around here. If we had that premium emote like VMe, I would hit you with that lurk, but I do not. So, binary operator, get the context. Binary operators with the symbol of the expression. If expression return type of the left-hand side does not equal the expected return type of the left-hand side, then return a type error. So that's probably what was our, no? Why are we getting a problem? Oh, that's a big issue. So if result is null and we break out of here, we just, you know, casually dereference null like it's nothing. So how about we do something like this? If result, then do result type. Otherwise do like -1, something that doesn't make sense. That will at least prevent, nope, still doesn't prevent shit. You'd think. So we're writing into result without allocating it. Why have we done this? Then I don't have to worry about that. I do have to worry about that though. Int out equals that out. There we go. That's better. And all we have to do is now fix this. So if we handle it incorrectly, we return the result type, which is likely 0. So we'll just set result type to -1 right away. There we go. Look at us. Okay, so the idea would be to, in the case of trying to get the return type of a binary operator, type check that bad boy and make sure it works too. And Rohan says, and all we have to do now, ... is to finish the compiler, Kappa. Lamau, or Kipo. You're right, that's it. How hard can it be? So this is a binary operator. So we just want to type check this program. And then, after type checking the binary operator, does it return? Type check program returns an error, but this returns an int, because this returns a type. However, type check program returns an error that has to be bubbled up to here, through here in this case. Or we'd have to handle type checking of binary operators and unary operators specifically in the binary operator. Left and right hand side handling. Okay. What if we did, we could move the int into a result like that. Lander XT says, why finish the compiler when you can leave it unfinished? Work for 178 hours on the README and piss off generations of people in GitHub who come across it. That's what I do, baby. Eternal Wild Fox says, and the linker. Lamau. We're not writing an assembler and a linker for x86-64. We'll get to that if we get to that, but I don't think we'll get to that. Why are you mad? Oh, because this is named result, so this is going to be type. Yep, sure. And then we're just gonna go fix this. Oh, there's no, okay. Didn't need to fix anything. So we'll just set it to -1. And then at the end here, we'll just return okay, but return, we need to set type to the results type. So in this case, we can now not return expression type, but we can say type equals that, and then return okay. It's pretty concise, Lander XT says, this has been archived. Check out funcompiler-ng at this link. Oh god. The public archive. Also, that should be expression and not program. Okay. Yes. And the idea be that this returns an error. And we just need to set this to that. And type check expression needs to end up in the header. And so can expression return type. Why not? Eternal Wild Fox says, I wonder, do I really want to learn how to make a bootloader right now? Or do I want to keep working in PHP? The cool part is you can do whatever. That's also the bad part, because there's no, like, push towards one side or the other, right? If you're having a hard time deciding, I would just go with one and stick with it. But in my opinion, I would just try and do as much as possible. You could try and do both. You know what I mean? That's why I try and start multiple large projects. Advice, don't keep working in PHP. Why, Landar? Why? We love advice around here, but it has to have reasoning. You can't just give advice like, do this. That's not advice, that's just like a command, right? Or a demand. Eternal Wild Fox says, I switched between projects already. Yeah, so you get it. Just create a new project in another language, that's all. Or like making a bootloader, for example. Landar says, I have something of a rivalry with PHP. That doesn't make sense if you have a personal rivalry with PHP to try and get others to not use it, though, right? There's no reason to spread that rivalry. So I'm curious why your advice to him was to stop using it. See what I'm saying? Because PHP is just fine. It's actually not a bad language if you work in it. If error.type, return error. Rohan says, maybe I should get started with PHP then. Lamau, yes. The troll. Mr. Mugume says, propaganda is how you win wars. Stop using PHP. Oh, so funny. PHP is slept with Perl in its 20s. While they were married to Ada. Dun dun. We need to stop using PHP and use PHP emotes. We don't, though. We do, but we don't. We do, but we don't. So, effectively, this should type check the expression and return this error, bubble it all the way up. We're also going to have issues now calling this, right? Because this no longer works. We're going to have, oh Christ. Okay. Like that. Yes, like that. Hey, look. We simplified it. Rohan says, yeah, nay, easy. The emotes. Eternal Wild Fox says, to be honest, PHP 8 is very mature and works great, pretty fast. Absolutely. It's very performant. It can be like, it has multi-threading kind of embedded, if I remember correctly. It's really cool. LanderXT says, a counter-argument to my pointless hatred. Rohan says, wait for PHP 9, Kappa. It will be over 9,000! Eternal Wild Fox says, PHP is non-threaded. I see. I don't know what that means. but it sounds cool. Not as fast as compiled programs, though. It's true. Compiled programs will win just because they can be optimized much more. Especially because since they tend to use like static typing. PHP is single-threaded. I see. That makes sense. Which one? I thought PHP was good with concurrency for servers. I could be wrong. I could be wrong. Yes. So we get the return type of the left-hand side, the return type of the right-hand side. And then we ensure the left-hand side and the right-hand side match. We ensure that we don't need to ensure the return type because that will be handled in return type. Look at us right here. Landor XT says, how to use threads in PHP? Step 1, don't. Exactly. Eternal Wild Fox literally said, you don't. Step 2, uninstall PHP. Lamau. Those are good steps. Those are good steps. No, they're not. PHP's fine. PHP runs the world still. People, please, Eternal Wild Fox says. Exactly. It's just a language. It's just as valid as any other. Still useful. Still fast. Still works. And people know it. Hey, we got someone new in the Discord. If that was you, thanks for joining. I waved from my phone, so it's the other account, but it's still me. PHP is in the top 5 asked programming languages in the world, I believe. It's very popular. It's used in a lot of web frameworks, so it's like, it's not going away. People just hate it because they had to do it at their job or something. I don't know. Hey, Lando, I get that way. They'll dynamically write out entry point scripts and then spawn sub-processes to run them. Gnarly Quack says, how's it going, Gnarly Quack? It's great to see you. Thanks for tuning in. I mean, that sounds fun. I feel like doing that in C is also something that would be fun to do. And it's literally how C works. You know what I mean? Like, to create new threads. The interpreter is actually thread safe, but for some reason it's not enabled by default, so you need a custom compilation to get multi-threading. Sounds like it's on its way then. In a few short years it'll be happening. So the return type should equal... So we have to get this binary operator from the environment. This thing. And we would like to return result type. So we just break. Also, we should do something like this so that we can break, and then we will free this memory and it won't be leaked. How about that? How about that? Alrighty. I guess I could just do this. And then do that. I guess I could just return error. And then break. A little better. A little better. Gnarly Quack says, and then install a couple C extensions. Oh lord. The worst thing in the world, C extensions. Gnarly Quack says, anyway, I'm doing well, Lenzer. Congrats on becoming an affiliate. Thank you, Gnarly Quack. I appreciate it so much. I totally got cucked today by Twitch. They only counted 49 out of 50. I don't know when. They update it daily. I don't know what time exactly, but they counted it at 49. I'm so cucked, but I'm still at 3 out of 4 things. I just have 49 out of 50 followers on the counter. But when I go to my channel, I have 50. So it's like, I don't know what they want from me. It's fine. Once it actually, tomorrow it'll be 50. I'm sure it just has to take time to update. But then we will be affiliate. Eternal Wild Fox says, are you muted now? I hope not. Am I muted now? Can you hear me? Hello, hello? Landar said, I unfollowed for 0.1 seconds just in case Twitch decided to take the account just now. Hopefully not. They're gonna put me at 49 again. Oh no. Gnarly Quack says I can hear you. Awesome, awesome. I'm not muted. That's good to know. Eternal Wild Fox says, okay, time to install an emulator. Going to try the bootloader. Are you muted now? I'm not muted. But that's really awesome. I recommend QEMU, but use whatever is the best for you. Hey, my internet went out. No! Hey, it's back! Am I back? Did I reconnect in time? My internet went out for a few seconds there. Did you mute the stream accidentally, Lamau? Twitch is terrible with their UI, to be honest. I'm just gonna say it. Result contains a function node. I don't think I finished that. In any case, we type check this binary operator, and then we return its result type, which is going to be wrong. We actually need to return its type in the type's environment. Oh, Christ. So we're going to have to parse get type from context, the original context. We're going to have to keep here as well. This is terrible. Hopefully this all changes. So I'm just going to type it. Original context from result children next child, its return type, and we need to get it into result. Why not? Should that be okay? I don't know if that's okay. We'd have to look at parse get type. Can result be the same as our ID? I mean, yeah, we just read from the ID and then update result and then don't do anything. So yeah, that's fine. So now result should contain the proper type. Hopefully. Printf, LLD. Give me that result type. That's an int, not an integer in our language. Too few arguments to expression return type. Yes, that would be true. And if type does not equal result type, problem. Hey, look, that's a little better. We printed this node, which I presume is from somewhere up here. I don't know why. We never printed out this, it doesn't look like. So in this type check expression, we got back here, and then left-hand side was an integer, should have returned integer and done everything. Interesting, interesting. So left-hand side of binary operator does not match declared. So what got returned here? When did we return? How did we return? Right? So are we here? I just need to see. This is how I'm going to do it. We are not here. We are here. So we print something out, and then we say here. Why do we print something out? It's a little interesting, is it not? It's not a function call. Oh, we printed out if node... Okay, so we're printing out each node. We're saying that this one didn't work out. Then we say here. So when we check out here, what if we put that in here? We still are here. So we are returning an error from type checking the binary operator multiply, which is interesting because the binary operator should get the return type of the left-hand side Eternal Wild Fox says, no. Mr. Mugume says, I'm trying to get sub 10 minutes on 195 countries of the world, but my hands are too slow and I keep misclicking, man. That's crazy. I'm not that smart. I don't know geology that well. Geography? One of those. Geography. Gnarly Quack says, the cucking is just beginning. They also only pay out once your balance reaches $100. Who pays out when your balance is $100? Eternal Wild Fox says, the sound was gone. Lander XT says, you didn't go at all for me. Gnarly says, you were buffering for a second, but I never lost audio. Landar says, MI9, the British Directorate of Military Intelligence Section 9, was a highly secret department of the War Office between 1939 and 1945. I don't see how that's relevant, but okay. Rohan says, so we're here, and here, but not here. You understand that we're here? Lamau. Debugging. Printf debugging. We are type checking a node, and effectively, Landar says, I can just make you read any random sentence. Pretty much, as long as it's not offensive, yeah, I'm gonna read chat. And have that on permanent record. Sure. Yeah, go ahead. Don't use my voice for anything without permission, but yeah, it's on record. Mr. Mugume says, if you play the country guess game all day in school, you will start to know the countries. Lamau, you're probably right. So when we type check this one, we get an error that the left-hand side doesn't match. So what are our types? Right? I want to say expected type, bleh. Ah, see, this is a symbol. This is why. I already know why. We're going to need type 2 as well. This is going to be a little messy. We're just going to say expected type and hope that we need that elsewhere as well. So then this symbol, we have to look up in an environment, which would be the original context, types environment, this symbol, and write it into I guess I could just do temp node, and then I don't need expected type. That's fine. Yes, that's fine. Wait, so what is value used for? It's used right here. Okay. So we could probably get into value. It's probably not a big deal. In any case, it doesn't matter. So if the type of this does not equal that, so we have a binary operator, we type check, we get the data for the operator, we get the return type of the left-hand side, we get expected return type of the left-hand side, and then we compare them. And look, it still did nothing. Wonderful. So what are we expecting? Can you print this node for me as well? So this symbol should be what we're expecting. It should be right above. Yeah. So we have an integer. That's exactly what you think we would have. Because the return type of this should also be integer, right? We can printf our type, which is type. New line as well, so we don't break things. Type of -1. Hey, we're starting to get it now. Ah, I didn't use parse get type, which searches the entire chain of contexts for a type. It goes all the way up to the parent. Gnarlyquack says that was in response to you complaining they weren't counting all your follows. Oh, Lamau. Gnarlyquack says Twitch, apparently they only pay when your balance exceeds 100, so the amount of your cheers, subs, etc. have to get over 100 before Twitch gives you the money. That's pretty standard. That's why I have that Twitch, that's why I have that PayPal donate button, buddy. That goes directly to me. That's why I ask people to hit that. I'm not really going to ask people to subscribe. They're just going to be able to if they want, like, Twitch emotes. Lander XT with the follow 10 minutes ago. So from our original context, get type, please. Still no? We still got -1. Why'd we get -1 in type? So expression return type. It equals -1 here. But then we update it to result type. So we have to update result type in here. What if we just don't do that? So somehow now it says I've been following since 12 minutes ago, so if anyone clicks on my name, they'll think I'm new. That's true. As soon as you start getting channel points, it's not going to work anymore, though. Which is probably tomorrow. Or whenever Twitch Daddy Bezos allows me to get them, right? So the idea would be error getting type. I don't see that. So we're not here. Are we here? We probably are. So we need to just have it work with 2 integers is the problem. It's not working with 2 integers. So expression return type of an integer should be the expression type. I don't see why this doesn't work. So what do we have before? Let's check that out. Typechecker.c. All hail Bezos. Lamau Landar. So before we just returned the expression type. So result type equaling that, and then type equaling that. We should definitely set type to the expression type of an integer, right? So what's happening? It's like we're going here and then it's not being set. Could mean that we have an error. So why do we have an error coming from here on a binary operator? Right? Well, because the left-hand side type doesn't match. And why doesn't the left-hand side match? I don't know, because an integer should return integer. I don't know why it doesn't. Because if we take a look, binary plus, binary operator multiplies as mismatched types, -1. But that's only happening because we don't reach our full potential. Gnarly Quat. Oh, Rohan says soon TM we can enable caps lock via points just to mess with your coding. Look forward to use those points. Why not, Lamau? It'll be fun. Gnarly Quack says, yeah, but in a world where microtransactions are a solved problem, I personally find it unconscionable how Twitch takes advantage of small streamers like that. It's not really taking advantage of small streamers, in a sense. It's just storing their money until they have enough to warrant paying for the payout. Lander XT says, I think we should have delete 10 lines of code for like 1 million channel points. That's probably worth it. You could just enter an Emacs command and it would do something, right? That's a good idea. Type check this operator as well. So we type check this expression. And then let's just print the error and then exit, right? Crazy stuff, I know. We get a binary operator with multiply that says mismatch types. Right-hand side expression does not match declared right-hand side return type. Alrighty. So the fact that the right-hand side doesn't match, let's go check it out. Oh, did I just forget to do the right-hand side down here? Yeah, I did. Look, I'm still comparing it to a symbol. Now I'm wondering why it doesn't work. Christ. Of course it doesn't work. Right-hand side. And temp node. And okay, so we have type does not equal temp node type. Return type of right-hand side. Hey, look, it type checked. Hooray. So now if we tried to do something, what are we parsing? Math. Now if we tried to do something like 2 plus 1 plus, we don't really have other types, right? But we could do foo, and it'll say, hey, that doesn't work. Ain't that beautiful? Ain't that beautiful? So now we have type errors for binary operators. That was rough, but hey, that was a good start. I can also remove all this crap. I could say like expected type if I really wanted, but it doesn't matter. Let's print the expression that had the error. Gnarly Quack says remove -r/kappa. Oh Christ, you scare me. Gnarly Quack says need more pointer dereferences. Lamau. It's never a bad thing. It's never a bad thing. So the idea, you could probably do this also to make you happy. Spresian. Error arguments. Type check expression. Arguments must not be null. Look at us. Node child, sibling, cousin, friend of significant other value. Lamau. You probably haven't seen Lisp code, huh? the Lisp interpreter code. It's the same way. It's just doing tree traversal. And if you look at C compilers now, they're the same, but these are all hidden behind like macros. Gnarly Quacks is not since college. Is that a diss? Oof. Lander XT says 1 quintillion channel points and you delete your entire OS. Lamau. I wouldn't do it. I wouldn't do it. But I remember stuff like parenthesis, 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 foo, 1, 2, blah. I see. Basically, when you write Lisp, let's just go look at my Lisp that I work on. What is it in types? When you write Lisp, you deal with a recursive pair structure. So you have the same linked dereferences. if that makes sense. So an atom can point to a pair of atoms. So one atom can have a left-hand side and a right-hand side. Basically turns an atom have the possibility to be a binary tree. So these car and could'er are actually just chains of dereferences. And a lot of the times you have car, could'er, and stuff like that. Lander says, I'll sub for a year if you install Linux. I'll dual boot Linux. I'll do that. I don't care about that. I just need an SSD. Rohan says, I've never seen anything like this, but I just started my education in programming, etc. That's fair. This is pretty rare to see, in general. Gnarly Quack says, no, not a diss, just traumatic memories of excessive numbers of paragraphs. I think you mean parentheses, but I get what you mean. But yeah, when you use car and get the left-hand side, it's actually just a dereference. And if we go take a look at like some of the built-ins, whoops. If we take a look at some of the built-ins, you see the same thing where it's like the could'er of built-in args. And it gets worse. You know what I mean? A lot of dereferencing. Landar says, I dual boot right now. That's awesome. I think dual booting is the future. I think all three OSs, the mainstream OSs, should all be available on every computer. You should just boot between them for different tasks. Gnarly Quack says, yeah, parenthesis. See, I'm still so traumatized, my brain won't even type the right word, Kappa. Lamau Gnarly. Mr. Mugame says, I think I haven't told you, but I use a VM. You've definitely told me. That's cool. I can't stand working in a VM. It's cool that you have it working. For you. So, function call return type. We still need to look up the function in the context. Right? So result contains a function node. Then we just actually need to return and say result equals result children next child. But then we have to say, right, we're going full, this is now a type symbol, right, a return type symbol of the function. So we have to resolve this symbol in the context, in the environment that we're in, using, so result and parsing into result. I think that should be okay. So now a function call should return the proper type. So now if we do something like the fun foo integer, should this be allowed? I don't even know. So let's think about this plus foo. Exited abnormally. It's fair. So it probably has to do with this result thing. And I think the only solution is to have another dang pointer. Node pointer, temp node, why not? Why not? Okie dokie. Landar says, what about IBM OS 2? That's not a mainstream OS. Gnarly Quack says, I haven't run Windows in over a decade. Whenever I hear stories about Windows update issue, I just grab my lawn chair and head to the beach with a beer. Lamau. That's a good tactic. It's a good tactic to stay away from Microsoft. But if you use GitHub, you're still a part of it. It sucks. They take over everything that's good in the world and use it for themselves. It's like, or you could not do that. Ooh, big error codes. So I can't change these pointers. So I have to dereference them. Hey, look. We just type checked a function call. Ain't that cool? I don't think we code-janned a function call. We did not. We did generate the function that does nothing currently. LanderXT says, I think everyone should dual boot DOS union build of MS-DOS 7. Lamau. Gnarly Quack says, true, I actually prefer Bitbucket, but everybody's on GitHub. So, Eternal Wild Fox says, that is awesome. Yes, we are type checking. So this function call to foo returns an integer, so it goes, yeah, you're correct, bud. And we can't we can't necessarily test by putting another type in here because there is no other type yet. But it still works. You can see that the function call foo says, hey bud, nah, right hand side does not match. Then if we did that, I'm sure it would say left hand side. We got to get better at pointing within this AST to the proper node that is incorrect. Because you kind of have to do some searching, like, okay, the left-hand side of one of these is wrong. So is it, you know what I mean? You just have to search for it. But it's the, I guess that's the right-hand side, which is a function call. But that becomes the left-hand side of this binary operator. So it's a little confusing. It's a little confusing. Eternal Wild Fox says, plus foo? I would make it more simple. Oh, wow. Lander XT says, Microsoft, we totally support open source. .NET is on GitHub, yay! Also Microsoft having a monopoly on OS market share and aggressively pushing Edge to all Windows users. That's true. They do much worse than that, too, with all the, like, they take advantage of old people, in my opinion. Like the people that don't know tech as well. They're kind of like scammers, they're just not as bad of people. You know, the, like, scammers who call the elderly and they say like, give me your money, and they end up like screaming at them over the phone, and the old person is scared and they're like, oh crap, I owe someone money, I gotta pay. And then Microsoft is kind of like that. They're like, oh, these old people don't understand anything, we can sell them whatever we want. It's really sad. Gnarly Quack, embrace, extend, extinguish. That's always been Microsoft's strategy. You're correct. And then patent it. You forgot the patent part. Lander XT says, I signed up for Codeberg, then went straight back to GitHub 5 minutes later because GitHub actually has users. So you only care about code? Like, why does GitHub having users matter to you? What's the difference between users on GitHub and users on Codeberg? It's just the number. Why does it matter how many users there are? I'm honestly curious. Gnarly Quack says, I don't doubt that's underlying their Linux subsystem, etc. Yeah, I think they're going to try and take over Linux and start patenting stuff with the Windows subsystem for Linux, but it is helpful for us right now. Eternal says, save the line number and column in the tokens. If you have an error read in the file, go to the line and column and show 10 chars before and after. And show that line in the error. That's a good tactic. That's a good tactic. We don't actually have tokens anymore. We discard tokens as we stream them. So the lexer lexes tokens for the parser, but the parser generates an AST, and then tokens are gone. All we have is the AST while type checking. So for errors and stuff, we're going to have to store the span in the node. And if you take a look, I've already documented this right here. LandRXT says, then there's Google, make an amazingly useful product and kill it off when everyone's already adopted it. That's right. Stop supporting it right when it needs the most support. That's Google. They're like, oh, you guys all want self-driving cars? Good thing we won't say anything about this ever again. Eternal Wildfox says, makes sense, a streaming parser. Well, that as well as the parser should, nothing past the parser should require the lexing tokens, if that makes sense. Or did I misunderstand you? No, you understood me correctly. the parser is streaming, but because it's a compiled language, you have to compile the entire program into a single node. So the streaming really only takes place within parsing a program, if that makes sense. But it does work. But then once we parse, we then have this entire built AST that we then type check and code gen. But you're right, for errors, we have had this for a long time. We need to get better errors. Let's go do this. I'm kind of tired of seeing this. Let's just go add to our parser and go parse integer. Perfect. All right. Does string to long parse negative numbers? I guess that's all we have to test. Let's check it out. So in math, right, -1. Actually, let's just keep it a unary operator. I think that's fine. I don't think we have to parse negative integers like that. It does work still, though. Look at that. So we already parse negative integers somewhat naively. Mismatch types, because this still returns none in our little test. Oh, wonderful. Goody goody gumdrops. Does it have to do with that at all? It did. Interesting. What did I break? With the -2. Oh, it works now. Weird. I must not have saved the file. We're also printing out a lot of things that we don't really need to be printing out. But it's fine. So, and this code gens... Yeah. Is that allowed? I don't know if that's allowed. Chat, do you know if this is allowed? Does assembly allow negative numbers? I guess we can just test. Let's try and assemble it with the GNU assembler. Well, it succeeded. So I mean, I can't be mad at that. We can link it, and we can run it with code 4. -6, -5, +2. That would be -3, I believe. Right? If this returned, we don't pass any. Why are we not failing? Don't we type check the amount here of arguments? Shouldn't we fail on the amount of arguments in the function call? No? Let's figure that out. So the type checker in a function call, we say there's either not enough or too many. So why are we not hitting this not enough? If temp node does not equal null, value children. What is value? Value is the function. So this function has, yep, that should be the first parameter. And we say while iterator and temp node go ... and iterator should equal expression children. So this is the function call. So iterator contains what we passed. So what is this actual expression? Can we see that in here? Function call, we have none. Interesting. We have none. So while iterator and not none-p, iterator, is that what we have to do? No. Still didn't work. Oh, did I put these in the... yeah. I think I put these in the wrong spot. Because we want to be able to pass none as... I think it should be like this. And then check iterator in the same way. And in this way... Nope. Darn. So none, we have none, none, which means that this value, children, children, value, children, temp node value. Oh, that's the function. That's the function. So value, children, children gets us to the first parameter. And then expression, children, next child, children. So expression is a function call. Child, next child, children. So we get both of them on the none right here and here. So this would be our iterator, and this would be our temp node. And what's happening is we get the type of the temp node. So we get this type integer, like this actual type value. So that we get the return type of this symbol, the actual number. And then we get the return type of the expression of the iterator. And then if type does not equal result type, we should say argument type does not equal declared type, which should be happening because we should get integer and none, right? So something's got to be happening here that's a little funky. Let's get rid of our little hacks to try and fix it. Eternal Wild Fox says, does it also work after the plus? Not sure. We are not sure. We are not sure. We're never sure. But you don't have to be sure. You just have to make progress. I don't know why it don't work. Function call none none. So none does not equal an integer. Why happen? So we're going to say type and results. Type. And then just set those. Visual Studio installed 20 gigabytes, lol. Yeah, Visual Studio is incredibly large. It sucks. So we never see type. Well, that's confusing. That's very confusing. We do bubble up the error to main.c. In typecheck program, we print the error out if we get it. From typecheck expression, we bubble the error up right here. Is that with or without the SQL Server Database Managers installed? DBMS, is that what that is? They do just install everything by default. It's pretty bad. So if we're not getting here, why are we not getting there? So when we are parsing, we should get here. Type checking, it's fine. We never get here. So node type function call somehow isn't being type checked, which is interesting. Because we have a list which contains a function call on one side. And we type check the binary operator itself, but as far as the left-hand side and the right-hand side, we just use their return type. We don't actually parse the function call. Interesting, interesting. Software in 2022, 20 gigabyte text editors not including dependencies. Lamau. I installed C++, C#, Python, and Node. Oh, a lot of that was probably Node then. And one I forgot. No, that was it. Nice, it was just those. It was probably Node was a large part of that. C# isn't small either. That's insanity. That's why I use Emacs and MinGW. It truly is minimalist nowadays. Okay, so how are we missing an expression? When we type check a binary operator, we should also type check the left and right hand sides. Okay. So first we need to type check. Type check all children. I guess for every node we should type check all the children. Should we not? Every node should have all of its children type checked. Right? Is there any reason not to do that? I don't think there's any reason not to do that. So we're just going to say iterator. We can't reassign that. We're going to have to say node pointer expression iterator equals expression. Expression iterator equals expression iterator. Next child. Is that true? So we should have child iterator. And iterate over the children of the expression. And for each one, this is making sense now. Do a little bit of recursion. Okay. We got here. So that's better. And what do we get? Recursoring. That's right, we're doing recursion. It's in the type checker, which is in the, just has to deal with the AST. So it's definitely an issue that we'll have to fix, but we can just use continuations and it really won't be that bad. Or we can use the, a different pattern, but it's fine. Not a big deal. We have a function which returns an integer, takes in none, and a function called none none. Does not it take in a parameter? Did I do this wrong? Does that matter? That doesn't matter. So for some reason our function has it has a parameter, x integer. It works. It returns integer. We have all the data we need as an x integer, but this function called a foo has none none. Says function foo, function foo. What is that coming from? What is function from? Should we grep that? Like, I don't even know how to look for that. And what is does anybody remember grep? It's -r and dot. Okay. Ah. You see that? I did error create instead of error prep. That's still not it, apparently. So how do we type, what is function foo coming from? Function 3, function 2. It's neither of those. Is this bad boy right here? That's one of them. I find very interesting. Okay, so we have function 1, function 2, both hitting, but then the error gets ignored. So where are we ignoring the return value of type check expression? It's probably in a recursive call. Yep, right here. If error dot type, return that crap. Thank you. Eternal Wild Fox says, you have a tree, why not use the visitor? And then he says, be right back. I would say don't use it because this is this is the visitor pattern. It's just in C. We're switching on the type of the expression, and then visiting that node, and then recursing based on the type of that node. That's it. This is it. I hate to tell him. I hate to tell him. I think that's how this should go. Type check all the children of node for type checking node. Onde. Okay, so we now effectively do this. It's working now. And as long as we don't ignore the return value anywhere else, it should work. Invalid arguments. Hey, arguments must not be null. Look at us. We did it. Arguments must not be null. That's not good. So context should never be null. We're just past context directly. And child iterator should never be null. Oh, but we're doing that wrong. Look at us. That's better. We did it now. Chad, it's working. Oh, Christ. Hey, look. Get the worked. And we even got to our, finally, our printout that we never got to. That one. Definitely don't need to print this. And then in CodeGen, I don't think we need to say this at all. Or do the corresponding print. Hey, so now we have a function, and that's our program. This is a little worrying. This is a little worrying. I don't think we did this right. I do not think we did that right. Something happened while parsing. What happened? How did we end up with such a bad... What happened? Okay, so we create a function. I just keep saying what happened. I'm so shocked. That should be... We have list of parameters. Oh, I'm an idiot. This isn't... This is wrong. We have an integer 2. So in parsing, if it's a function call, we parse the argument list, right? And that means that down here, we have dealt with it. But that also means that okay, when do we look ahead? Look ahead for infix operator. Yes. So we look ahead for this infix operator, and we continue if we find it. That's valid and everything. But a function call node never actually gets here because we only ever parse the arguments. So if we continue, we're going to lex further, which we don't really want to do. We would just like to say, hey, look ahead for this operator when you're done. So how do we do that? We have this function call, and once it's parsed, aka here, right? So in here, we somehow have to look ahead for binary infix operator here. Okay. And in doing so, that means that we have to somehow either move our control flow back to here, or we have to extract this into a function. But that won't work because we continue optionally, right? Because if we look ahead and there's nothing. Okay, so we're going to have like look ahead. Okay, so we're going to have like parse binary infix operator, right? That's what we're doing. And it's going to have a node pointer of the left-hand side. It's going to need like our context. So we're going to need our parsing context. What else will we need? So we're going to need the current token, the token length, and the end. So let's just do that. That is t pointer length and char pointer end. Should we put left hand side right at the beginning? Why not? So parsing this operator, we need these three things. We need the context. Gnarly Quack says visitor pattern is what happens to virtual tables when OOP gets its hands on them, and then goes on to say that virtual tables are the solution to every problem / rant. Lamau. Eternal Wild Fox says, I'm going AFK for some coffee and a break. I will be back after. Thank you so much for watching. Have fun on your little break and make sure to enjoy it. I'll see you when you get back if I'm still streaming. Okie dokie, okie dokie. Look ahead for binary infix operator. Gnarly Quack says, have a good one, Eternal Wild Fox. Yeah. I'm not a coffee person myself, but I understand the urge and what it's about. Because I like getting into certain cultures and it's like, ooh, this one is smoky. This one is roasted. This one, and it's like you just get your different little options, right? It's so much fun. It's like little compiler flags for your coffee. What's it gonna return? Probably an int. And if it's like, well, it's gonna need to return an error. So we return an error, or if we don't return the error, we're gonna need to say whether or not we found the thing or not. So we're gonna have an int pointer and say found. And then we're just gonna say set found to 1 if an infix operator is found, and parsing should continue. Otherwise, 0. Okay, so along with this, we're gonna have to update our result. So we're gonna need both our working result and, oh boy, and our precedence. This is getting messy. It's fine though. It's just a lot of arguments. It's not the end of the world. So now we're gonna need precedence and working precedence and result and working result. Not too bad. Gnarly Quack says, I literally have a cuppa sitting next to me. Hehe. Nice. It's all fun and games. Parse binary infix operator. You know, just a simple function. Oh man. It's fine. Everything is fine. Okay. Bring me back. Do the thing. And paste the thing. Now think about how thing work. Yes, token length equals length. Why are you mad? Current copy declared here. Undeclared identifier current token. Oh, it's saying I'm accessing it incorrectly. Because I have to say, hey, if it works, update the length. And the end. Okie dokie. I guess you don't have unused turned on as a compiler warning? Hehe. I do. I'm pretty sure I do. Yeah. Oh, continue statement not within a loop. We can fix that. Because instead of continuing, we should just say break, right? No, there's no loop. We just have to return and say found equals 1. Otherwise, found equals 0. Yeah, why not? I don't know really where to set this, so I'm just gonna set it here. I guess I don't. No, oh, that's right. So in the CMake, we were doing Visual Studio stuff, so I turned all the errors off. We can do it now. Hey, look, all the errors. It's beautiful. It's a long. Is that what you're saying? Oh, it's a size T. Hooray, errors, or warnings. Variable error set but not used. That's fine for now, because we're about to use it. Comparison of integer expressions of different signedness. Yeah, we're working on it. We're working on it. Lamau. Thank you for reminding me to turn the errors back on, by the way, or the warnings. Always forget Visual Studio doesn't allow those flags in CMake because they're evil. No, they're just a little, so precedence should just get passed as a number, but working, I guess these should be pointers as well because we have to update them, right? Precedence is something we calculate, is it not? I don't think we need precedence like that. I think we just need working precedence as a pointer. So dereference this pointer, and then we can update this pointer to the precedence that we calculate. Gnarly Quack says, I was chuckling when you wrote that long function prototype and then just put return OK in the body. Lamau. Yeah, if only every function were that easy. That's right. So the problem, did we just jump somewhere else? I think we did. We don't actually use error? Lamau. Why not? We don't really return errors in CodeGenning. There's not a lot of errors to happen. You just write to a file. We'll do that so it stops complaining. Hey, look. Ooh. We'll do a complete rebuild to get all the warnings back. Comparison of different signedness, long int, and size t. Then let's make it a long int, shall we? And then this one says left-hand side is not used. Yep, that's fine. So the fact that left-hand, ooh, also this is a problem. The fact that left-hand side is not used is because left-hand side is actually being passed in already as one of these. That's what this does. In any case, we're much closer. We're still not using it though. So the idea would be to go and replace the code that currently is there with what we just wrote. And hopefully not have it all go wrong, right? That's fine. We can comment it out like that. And we would like to say error is equal to parse binary infix operator. Given the context, I'm going to say int found equals 0. We don't need the left-hand side. This is going to be called current token. This is going to be token length. This is literally just end. Precedence, we don't need. Working precedence, we do need, and then we need the address of it, I believe. Result and working result should be named exactly, and this is pointer. That's not the end of the world. Ooh, it don't work though. It don't work so good. It don't work so good at all. What happened? So the right-hand side was not parsed into. Oh, because of that. Oh. That didn't work. Why did that not work? What did we screw up? So we're getting some sort of access denied error. And the issue comes from probably one of these arguments being passed incorrectly. So we have a context pointer, a found integer pointer, a current token pointer, a length pointer, an end pointer. Long is a working precedence. Result is result, and working result is working result. So we have to, one of these is not a pointer for us. Working result's just a thing. So we actually need a pointer to update this pointer passed to that function. Because we have to update this pointer in place. Just like working precedence, we need a pointer to it passed to the function. So we need a pointer to this pointer passed to the function as well. So working result gets doubly indirected. Not precedence, result. Because it is a pointer, but we also need to write to it here. See? And then same thing here, dereference it. Still doesn't work, wonderful. Oh, because we just passed the wrong pointer. Hey, ha-ha, yeah, pog. So now it's this easy to parse an infix operator anywhere we want. How fun is that? If it works, update current token. We definitely do that. Yeah. If no more stack parser context, no more parser stack, return result. Return with current result. Yeah. Otherwise, handle parser stack operator. Sure. Good enough for me, good enough for me. So now, also this is not going there. It's already there. Okay, so now we just need these 3 lines. And after a function call, it's not the cleanest code, but hey, and it doesn't work. No, it does work. So we have plus with a function call in it. Yeah, everything works. It works. Hooray. And we have a mismatched type somewhere. I don't know where it is, actually. Does anybody know what that mismatched type would be? Int -2, int 3, int 1, function call, int 2. So this binary operator has the left-hand side. but then anywhere in there it could go wrong. So because of this message, but what did we print first? We printed this plus. So it says the left-hand side expression of binary operator does not match declared left-hand side return type. Is that true? It should, because we have integer hopefully spelled correctly in all of these. It should just all be integer, everything. So what mismatches? This binary operator plus, so the function call foo on the right-hand side could be on the left-hand side of this operator. Interesting. So it being on the left-hand side of this causes this error, but this shows that it could be the right-hand side, the function call not having a proper return type set. So we're just going to printf that type. Why not? We get type 1, then type 0. Type 0 would be none, right? I don't think this returns none. So we should probably do error, if error.type break. Then we get type 1. So we print it out once, but the type 0 does not happen anymore. But what happens to this error? Nothing. So now we just have to do this in a bunch of places, I'm sure. Oh, and also, yep, this error. It shouldn't error, but there's no reason not to check, I don't think. Alrighty. I've been streaming nearly 2 hours today. I would like to thank everybody so much for watching. Be sure to hit that follow button. We already have 50 followers, so we are a Twitch affiliate officially as soon as Twitch hits their little switch. And so we don't imperatively need followers, but we still love to have you in the community and sometimes be notified when I go live. If you'd like to be notified every time I go live, be sure to check out the Discord. It's in the About section of Twitch, and we all have a lot of fun. See, Fawn's joined today. How nice. Yeah, we all have a lot of fun and all talk to each other. I really recommend it. And yeah, join the Discord. The YouTube down below has VODs if you want to check out my previous broadcasts. And then there's that donate button. If you have a few extra dollars and the kindness in your heart, I would greatly appreciate any and all donations that come in. I will read the message as long as it's not offensive, and if you leave your username, I'll attribute it to you and say how much you gave. In that vein, I would like to thank the 2 donators I've had so far, ever. VMe for giving 1080, and Steve SF. He didn't give a username, so and he gave a very cryptic message. That's R3VUYXGGBGJOL. So I'm not sure what that's about, but he gave me 1337. So thank you for that elite dollars. I thank both of my donators profusely, and we appreciate having them around. Everyone that's watching, don't feel like you need to donate to be appreciated. All I care about is that you hang out and are around, because it's so much fun to just be able to talk to the people in chat and also know that I'm not alone programming. There's somebody out there going, that is what he's doing. Right? And I love when we can spread education and knowledge throughout the universe. So let's do that. That's my little ad read done. I can now continue and drop back into my programming persona. We need to handle a bunch of errors, because we didn't when we wrote it. Where else? That should be it. Hopefully that's it. Eternal Wild Fox is back. Awesome. Hopefully you enjoyed your coffee. Type is not found in environment. Ruh-roh. First time chat from a new viewer. John Hillington says, compiler programming is just checking for every edge case. I remember when I did it, I literally forgot to consider assignment in an if statement. It's possible. But yeah, you're exactly right. It's just handling every single edge case of tree operations and building the tree yourself and keeping context. So type is not found in environment. What type? What type? Yes. This is why people use go-tos. Christ. So we have type is not found within environment. I'm just going to printf what type. So we have the symbol. So we can say printf type not found. And then we can just say, put it in quotes and a new line. Type not found integer. Huh. John Hillington says, I want C to add defer. I miss it when I go from when I go to C. Yeah, having error handling like that can be useful. Because defer allows like if I remember correctly, it allows you to like say if anywhere within this place this error happens, then go defer to that. I don't remember exactly because I write in C where it doesn't have it. Sad moments. Type not found integer. So that means we're probably getting null. And we can just check that. Hey, look, it's null. So parse get type is getting null. And we don't know why. I now know why. So we say while context, which means that this loop only ever exits if we get it, or if we get to the parent environment, it'll be null. So then that would be an error. Still type not found. Okay. So we didn't fix it entirely. So get the type from the original context, not the one you messed up. Just to look for the function definition. So maybe we call it elsewhere. Parse get type uses original context in all these places, which is just whatever's passed to return type. So maybe expression return type. Ah. So we didn't pass in original context in that one case. So that still doesn't help us. We may need to do a debugger and do a backtrace because just to find where this errors. Because it doesn't make sense that we would have this happening with a null context to parse get type. Okay. Error equals parse get type. So for a binary operator, we get the type of the just the return type of the binary operator from the symbol. That makes sense. And then in function call, We call parse get type with original context. So could we call expression return? No, I think we check that. It's always original context, which is what we get passed originally. So it shouldn't screw things up. But it does. So let's see. Result contains a function node. Ah, I see, then we do this. So we could probably do this. Whoops. Because we free result, we shouldn't change it as a pointer. Can we do that? Did that work? What was I trying to fix? I don't even remember what I was trying to fix. Did it not work? Oh, Christ. It doesn't matter. So, if error type break, I feel like we should just put this here. I mean, we're going to return error anyway, so why not just break, you know? All it does is free it. Compilation finished. Okay. Well, it's working. Look at us. So now if we try and do some things that aren't allowed, like not passing an argument, not enough arguments passed a function. What if we pass too many? Too many arguments passed a function. This function. Not bad. Okay, now what if we remove the function call? -2 times 3 plus 1 plus 2. That looks about right. So now if we go to code.s, we have -2 in racks, 3 in R10. We multiply racks into R10, so -2 times 3. So R10 now contains -6. We move 1 into racks and then add R10 into racks, so -6 plus 1, so that'd be -5. And we move 2 into R10, so racks now has -5. We add 2 -5, 2, so this should be -3. Then we move that into the return value of the function. So, compiling this and running it, we should see a little -3 down here. That's exactly what we see. 253 is -3, but unsigned, right? Paug. That's dope. Very dope. So, our compiler now understands basic math. And very soon, we'll have function calls. I don't think they're quite there yet because the return value isn't set. And integers. I see. Shouldn't this self-evaluate? So we should like move here into here. I see, but local variable. Yeah, I remember now. I remember now. PushQRDX says, oh, sorry, I missed a few chats. PushQRDX says, C23 is exploring defer, but I doubt it will pass because it has a lot of other implications that might screw up the language for what it is. Yeah, I think it would go to C++ before it goes to C. John Hillington says, I was incorrect. Defer is a block of code run when something goes out of scope. Nice. Okay, that makes more sense. PushQRDX says also, hi there. Hi, Push. How are you doing? It's great to have you in. Thanks for tuning in. Eternal Wild Fox says, PHP also have goto. I never used it. That's good. You shouldn't. Goto is evil. Confusing control flows. But if you read the Linux kernel, get ready to read some gotos. C++ already has kinda its own defer using RAII. Is that the exception runtime? Is that what that is? I'm trying to remember. So, yeah. So I think a statement, I don't know. expressions can contain nested expressions. Can statements contain nested statements? Are statements recursive? Does anybody know? I don't think they are. I think that's the whole point of a statement and a declaration. Because if we have A is 4, then B is like 8. I don't think I want this to be allowed. Would this, because this would mean A is equal to B is equal to 8. I don't know what this would do. I don't think assignment should be an expression, it should be a statement, which means it doesn't return a value. Okay. PushQRDX says, no, that's the constructor's destructors. Destruction always runs automatically when object goes out of scope. Yeah, in C++ you have the like tilde destructors, right? Stands for resource acquisition is initialization. A stupid name, Lamal. It sounds fancy. Okay, well, we're now type checking. That's not too bad. Here's our issue and why we have to restructure things. Currently, when we create a function, for example, we create this context. And in doing so, this allows us to parse correctly and everything like that. But the issue is that this context, Jesus, you can see it just says, here we go. We never actually update the context parent, if that makes sense. We just update our node. So our original context, we're gonna say it's like an at, and then new contexts will be a line, right? So we start with our context of our at, and that's where our pointer is. And it's a linked list and points to nothing, right? This is points to null. But then when we reassign here, the context becomes a new context, then our old context, and then null. And our pointer stays here, right? So you see the issue is that from the top level in main.c, we pass in this context. That's all we have. We just have this parsing context. Like, that's it, right? So the issue is that this is kind of a backwards way of thinking about it. PushQRDX says, the other type thing you meant was RTTI, which is runtime type information. That's right. That's right. I remember having to deal with RTTI. Like, having to disable it was really hard when I was doing the OS at the very beginning. Because the runtime type information, it was trying to insert runtime information into a freestanding program. So it's like it's a compiler error already, but it's like this, I had to use so many flags to get it to stop. But then they updated it and it works better now. Classic GCC. You know a lot about like C and how it works, Push. That's really impressive. How do you remember all those acronyms and stuff? So we need somehow to have our context still be a linked list upwards, right? So we still need to have every context contain its parent. But then it should also contain references to the new children. And then each of these should also be able to have new context, right? But those point upwards to at. Okay, that makes sense. So we basically have to build another AST. That's not too bad, huh? So what we're going over, if you don't know, we're parsing the program, and during parsing, we would like to collect what variables are valid and where, right? So imagine that this is the global context. We'll just copy and paste this for now. We have the global context, which is the top level, and then you could have like a function foo, right? And this could be this scope. And here, let's do a real world example so it's easy to look at. Foo has the integer x bound as something in it, right? So it has x is bound to integer. It has to contain this mapping so that when we are within the function foo and type checking, and we look for the variable x, then we are able to actually shadow a global definition. Because if we have this, we would like that x integer to be here. And we would like to return when looking for a local variable, the nearest, or not looking for a local variable, but returning a symbol lookup in other parts of the compiler, then we want to get the local one first. This is called dynamic scoping, question mark? And instead of lexical? I don't know. I'm pretty sure this is dynamic scoping. Let me know if I'm wrong. In any case, you can see how this local context, or local context, why not, contains a scope. That's what I was saying. This local scope contains a variable, and we'd like to get this in case this is like a byte or a string or something else. We want the integer parameter in the function and not the global variable. Which means we have to keep track of our scope somehow, which we are currently not doing at all. We just have the one global scope. Push. Oh, answers my question, how do you know so much? Been nerding on languages and compilers for a few years now. Also, I love C++. That's awesome. You're one of the very few people I meet who don't dog on C++. Alrighty. Awesome. So how are we going to implement this very complex structure? I think we're just going to do an ordered tree. Is everybody happy with that? Is everybody happy with an ordered tree? So this would just be 0. And then in the code gen, since we're iterating over, when we hit our first scope, we just say, okay, we're at the first one. And then we iterate from there. So yeah, this would be like 0 scope. Then this would be 1 scope. This would be 0, 1 scope. Or 0, 1A, or you know what I mean? 0A, something like that. Okay. I also wonder if the parser context should be separate from the like compiler scope information. But for now, they need the same data, so they are the same thing. Alrighty. So I should probably do like this if I was going to do it correctly. That's pretty good. So now we just have to figure out how to create this. PushKiraDX says, oh, C++ is terrible in many ways, but it's also good. Every language is beautiful in its own way. We'll accept Haskell, lol. JK, lol. That's really funny. Haskell is a rough one. We're gonna make music in Haskell someday. So we're gonna be able to do it. So effectively, we would like to mimic our node, right? Because we have a child, which can have more children. but each one doesn't have to be a linked list. But it does, okay, but it does have to point up to the parent so that we can search upwards. So each one has to have a parent pointer. So we should store parsing context. I guess we'll just change what we have now. Why not? Where is it? Here it is. So we have a parent pointer, so used for upward scope searching, mainly. And then we're going to have a children pointer and a next child pointer. Because this will require multiple children. Anyone can have any amount of children. Okay. Used for entering scopes as different stages of the compiler iterate and operate on the AST. Sure, why not? So now, our parsing context has children and next child. First thing we're going to do is set those to null so we don't screw things up. So we're going to say parse create, context create. Yes, so here, set parent to parent. And then we would like to set parent child. So to do, add child to parent. Add this new context as a child to parent. Parent is equal to parent, but children is equal to null, and so is next child. By default, they have nothing. So parent. So we're gonna also, this is looking suspiciously a lot like the node. I feel like, okay, that's definitely a to-do, because we can do this. To-do, shove parsing context within an AST node. That's kind of it. That's it, actually. That's all. I thought there was going to be more, but that's it. Shove this thing, and we'll do that thing within a node. Because all of these things can just be represented within the node itself, I think. I don't think we need this fancy custom structure. And I think environments, if they became nodes as well, everything would be pretty hunky-dory. And we could use a more unifying structure type across the entire code base, which I think is worth it. In any case, we now need to have parsing context API, where we have parse context, and it's going to be add child, because we have to add to the end. I guess we'll do void. I don't know what to do. Parent is modified. Child is used verbatim. Good enough for me. So when we add this child, we just have to say while parent. So we're going to need a node pointer. Well, we'll just say parent is equal to parent children. While parent equals next child. So after doing this, if parent children, so we're not going to do null checking here. This may be bad. Fix me. Maybe do null checking here before dereferencing all these pointers. But for now, we're just going to do it. So then we can just set the next child to child. And that should be kind of concisely what we need to do. So now we have ways to, oh, also I wrote this in the header. That's a bit of a oopsie. Yeah, we'll just put it here. I didn't get that part. There we go. A little better. And so now we just have to say parse context, add child, and add the child to the parent. Child is called CTX in this case. I wrote that with nodes, like a dummy. See, they're already so similar. I really need to do this. They're the same thing. They're the same data structure, so I don't really need this separate thing. But we're doing it for now to keep it hunky-dory, everything working. Save myself a bit of time, type both at once. Wonderful. So now we add the child to the parent, and we definitely have to do null checking. So if parent doesn't have children, it's going to be different. The first child, right? The first child will have to set the children pointer and not really do much else. That's now much better and much safer, hopefully. So we add a child to parent. This may be null. So if it's null, we do nothing. Looks fair to me. Context. So the context we created cannot be null as far as we are concerned right now. We'd probably have like if not context return null, but just to deal with that here, in case this assert is like in case we're in release mode and the assert is a not. Okie dokie. So parent equals parent children. I see, so that's not going to work. We just have to say that. So we can honestly do that. Hey, hey, hey. Alrighty. Variable declaration X. Did I really write that? I did write that. I was like, wait, that's not right. But it is right. So the idea, can we now print out a parsing context? Do we print it top down or, oh, that's a confusing thing. What if we pass a node in the middle? So we'd have to have like print parse context for both upwards and downwards, like print parents, like print backtrace is what I'm saying. We'd have parse context print backtrace and then parse context print push QRDX with a newly colored name. I don't know if that's just me, but it is green now instead of blue. It says, wait, even in release mode, the assert still works. It's a runtime assert, unless you're compiling with ndebug, no? You're correct. But ndebug is like automatically added by CMake in release builds. So it's a CMake specific thing. That assert doesn't work in release builds. Because we can do this and it'll run, if that makes sense. We could probably just put an ndebug check here, but it doesn't really matter. Everything is fine. But yeah, you're correct. It is a runtime assert. It just CMake doesn't. It's not nice. We could undefine it, but I'm lazy. That's maybe a better answer. We'll just undefine it. Can we go do that now? How do I undefine a compile option? Do you know? I don't actually know. We're gonna have to look it up together. I think I closed my guest window in my browser, sadly. Oh, there it is. Oh yeah, makes sense. Also, the color didn't change. Back to blue. Lamau, you're right. It is back to blue. What was I looking at? I was looking at the fact that we would like to undefine something using Brave. So CMake undefine compiler definition. That's a bit new. Yep, that looks accurate. Yes. Oh, hey-o. Hey, look, this guy is doing exactly what we are talking about. Maybe you should look at this. Remove this definition from CMake CXX release flags. Well, I didn't set that, so... Great. Yeah, you basically just have to replace your D&D bug with something else. Well, that's not a bad idea. It's not a bad idea. So having a custom assert is a pretty good idea. CMake sets it by default on itself, yeah. Yes, it just doesn't make it easy to undefine it, if that makes sense. Add a custom CMake build type. I've never seen this happen. Okay. So we can either change CMake C release flags or C flags release, or we can change... See, remove definitions. I want that target remove definitions, though. Target remove definitions. They don't have it yet. It's fine. Alrighty, that's what I was working on earlier, or yesterday, I should say. PushQRDX says Lamau. So to answer your question, we can't fix that right now. Or I think that was my question. Can we just do that right now? We cannot. We're going to say, if not context, return null. Like good boys, so we don't start doing dereferences of null in this function. So now, I would like to be able to print a parsing context. So I'm just going to do that somewhere here. So we will print from the top down, I think. We'll say while children, for example. While child. So first of all, we should switch. No, we should just print out. See, we can't print out environments, which kind of sucks. We're just gonna do some helpers today. We're gonna have environment print be added. Look at us. Environment and sure. And to print an environment, we've kind of done this before. We just have to iterate over the bindings. Hello. So for each binding, we don't have to do any node compare. We can environment print. No, we just need to print F, the binding. And the binding should just be, I guess, print node, right? So ID symbol, what is it? It's value. Okay, so ID value. Print those two with like an arrow in between them and a new line. How about that? Could just use put C on an empty character, but I'll use put char and new line. And then we need standard IO here. Maybe LMNO. Okay. Assert is for suckers anyway. That's right, push. It's not, we don't need it. It's for nerds. While child equals child, next child. Okay. That should be at least enough for something. It is. And then we're gonna print, I guess this would be, yeah, environment print for child. Oh no, for the child we should do parse context. Yes, with the child as the top. We should also probably have a indent level. I believe. And then when we print our actual top, we will say each line needs the indent. We'll have like print indent, which is just going to be while and then we're going to say for the indent, put a space, please. It's not the most efficient, but it really doesn't matter. This is just for debug printing in any case. So let's see, this parse context print, we print this probably multiple times for each line. So what lines would I like? I would like to environment print the, let's see. Let's do the types environment. Why not? Which means I have to use the top. Types. I think that's good enough for me. Parse context print. Only used here. Okay. So then parse context print. I need this. Take it to the header. And then in main.c, we can use parse context print and pass in our contexts. Okay. It's beginning. Eternal Wild Fox says, learning CMake now. I want to do more C++ in C. CMake's a great start. It'll allow you to write cross-platform programs, which is definitely a plus of C and C++. I've been streaming over 2.5 hours. Thank you everybody for watching. Be sure to hit that Twitch follow button. Check out the Discord down below. Check out the YouTube. Be sure to hit that donate button if you are feeling ever so generous today. I greatly appreciate any and all donations. But let us continue. Let us continue. So we parse the program, and then we would like to print the context. Oh, but in print node or something, the issue is, do we print a new line? We print a new line. I don't think we should necessarily print a new line, but we need to if there's a child. That's kind of the thing. I see, I kind of rely on the new line. So we're gonna have the new line. And try and think about how to do this differently. I could have this be like node text, but that's not really that useful. Okay. So to print the context, the problem is that when we print the node in environment print, it's not really going too well. That's not really an option. So we are just going to have something like this. Yeah, that's what's going to have to happen. I don't think that's too bad. And then we can even put the new line here and this. In fact, we could even have it all in one. Look at us. We just need to copy this and then create that node text, which luckily we've already implemented most of. Oops. And then this will be just a node pointer node. So now, switch. Switch on the type of the node. I guess I just need to steal this. But instead of calling printf, I need to say return. I see. There's a small issue in that we probably cannot do things like this. So we're going to need the same, like a little static buffer. So we'll have the buffer size just be something simple. And create a buffer of characters. Eternal Wildfox says, add source to this project's executable. Add executable testproject.cpp, testproject.h. Meaning I have to manually add files, this. Yeah, that's correct. You don't have to add header files. They're automatically included from the implementations, right? So you only have to include your implementation files and ensure that the headers can be found that they include. You don't actually have to pass headers into add executable. Hopefully that helps a little bit. But yeah, you just add all your files you're using into your program, your project, and then it will build them. Pretty nice. So the idea, instead of having return, we're going to have to do like snprintf, and we'll start with that. So snprintf needs the node text buffer. It needs the buffer count, and it needs the format. Perfect. And then after we break, we can just, hello? What happened? After we break, we can just return the pointer to this thing, which is what? Eternal Wildfox says, nice. I'm in love with CMake already, lol. That's awesome. I'm glad it's working out for you. Why is this incorrect? Ugh, this is annoying. Yes, indenting, that is incorrect, believe it or not. Why you no do? What are you mad about now? Is that right? Okay, we're now at the correct position. So now we just need to snprintf into all these things. Why are you mad about node? There's just none of that. Somehow I removed the comma. But yeah, all I have to do is add sn printf, and then copy and paste. Not too bad. Hey, first time chat from a new viewer. How's it going, Cyber Patty? That's a great name. Cyber Patty. Okay, so node text buffer is now implemented. We can do our fancy thing if we need to. Nearly? What went wrong? Too many oh. We don't need an indent level. When we're just getting the text of a single node. We removed symbol from these, it looks like. That's not actually the worst to look at either. That works though. We have types happening, which is confusing, but that's fine. So now we just need node print, right? Print node. I did it backwards, but it's fine. So node text. And the issue, excuse me, Cyber Patty says some more Porth variants I see. Thanks, dude. This is not a Porth variant. This is actually my own compiler completely from scratch that I've made in the past 2 weeks. But I did make a program inspired by Porth called Corth, made in C++ instead of Python. Because Soding is such a cool creator. I do watch a lot of what he does, and he inspires me. Cyber Patty says, I know, right? I did one too called Torth. That's awesome. What'd you write it in? What language? Language. Interesting that I chose to do this check here. Oh, we linked it. I'm clicking on it. Stack-based programming language inspired by Porth. Nice. It looks like it's written in Python. Nice. Very cool. It looks, yeah, it looks like Corth. Compile and link the generated assembly. That's cool. You did it a very sophisticated Corth, though. I'm not that complicated. My Corth was barely Turing complete. Grammar 2 Parser Boy says, hello, how's it going, Grammar? What is going on? Why do we get types now? Ah. So these are our nested contexts, which we should have indent level added to that. There we go. So this should mean that a context with, yeah, each child should have indent plus 2 indent. So somehow we have a child with a child? Is that what's happening? So we print types. And then print the types environment. We do some more. I see, it's just this. It's just these. Cyber Patty says, see the self-hosting branch. I love self-made languages. Ooh, I'll check it out. So, this link. This screen. There's branches. Nice, self-hosting. Nice. That's very cool. You got it all the way self-hosted. That's insane. That's a lot of work. You have includes. Very impressive. Very, very impressive. You put a lot of work into this. Interesting. Very cool. Very cool. Thank you for showing me that. Be sure to check that out if you're interested in Porth. Everybody in chat. Okay. How's it going, Grammar to Parser Boy? Thank you for tuning in today. It's good to see you again. Oh. Okay, so the idea... Cyber Patty says, I did! It seemed like an impossible task until I implemented variables. At last. Yeah, not having variables makes programming very difficult. Just having the implicit stack that you have to keep track of is rough. Grammar to Parsaboy says, I am really excited. I go on vacation to see a friend far, far away by train. That sounds fun. You get to take a new adventure out into the world. And where you live, there's actually trains that go places, not just like are treated as like a museum, like in America. Because you guys are smart. You don't waste everything. Like, we can just use trains, guys. We have trains. So the idea is, I guess that I would need one of these each here. And then print different environments. Why not? So we have functions. What else do we have? Should have variables. We can do that. Or we'll do those first. Functions. What else do we have? Variables, types, binary operators. So we should do if top parent equals null. Whoops, I totally did that wrong. Then print binary operators, because operators are always going to be global for now. Yeah. They don't have to be, but they are for now. Much better. Very cool, very cool. So it's almost like environment print needs an indent level. Which would mean that before each one of these. Can you put a certain amount of characters? Is there a thing for that? So we'll just do that. And I'll indent it. Cyber Patty says, I love the readme of yours, by the way. Thank you. Thank you so much. Yeah, I took a lot of time on that readme. I wrote that readme in like 3 days. And I was like, all I've been doing is writing documentation. I gotta work on code. I gotta do something else. I was like, this is crazy. Perfect. What's your issue? Size T isn't a thing. I don't care if size T is not a thing. That does not affect my life. Now, I called them wrong. Oops. This is a messy screen. But it works. Okay, so now clean up a little bit. What do we got? So we have... That did not work at all. You'd think that for each line, this would print out the correct number of spaces, but no. Okay, so then we should do something like this, because these are kind of children to these. So functions, foo, symbol foo. What? Explain? Grammar to Parser Boy says, I will use the time to work on the compiler while I am traveling. That's awesome. Hopefully Backlang gets some new awesome upgrades, and I'm sure it will, honestly. Eternal Wild Fox says, nice, Grammar. Cyber Patty says, there are still some memory issues with my compiler, so do not expect it to work with every machine. But it does work on mine, so it's production ready, right? Cyber Patty says the Python version should work, of course. And then Cyber Patty asks, is this your intermediate representation shown in the right? Yeah. So this is my AST, or my IR, right here. This program is the program intermediate representation. As you can see, we have support for Lambda functions, first-class functions. We have support for binary operators with precedence parsing, so the multiply goes all the way at the bottom. Function calls with type checking, all sorts of stuff going on. And then currently we're working on the actual parsing context, so this would be equivalent to like the symbol table in C. Cyber Patty says lambdas are dope. I agree. I made my logo out of them. I have my welcome text editor is this. Cyber Patty says sick. Yeah. It's a thank you. I'm happy with the progress we've made so fast, because this is all in like 2 weeks and we have stuff up and running. It took me so long and it's so hard to understand, but it's worth it because it works. We're only leaking all the memory, which isn't a big deal because it lives till the end of the program. That's kind of best practices at the moment. So we can now print out contexts. So the idea would be that when creating a new context in the parser, well, I guess the idea would be to print out the context. Eternal Wild Fox says, in my Discord bot, I'm also going to use a Lambda as events with a client callback on connect and on message. Nice. Yeah, that's a really good use for a Lambda. That way you can call different callbacks. Very cool. So, okay, well, this isn't a great example. It's not clear where A or B came from. I don't think this is worth it. I'd rather have this error. So to do would be make errors better. That would be kind of number one, right? That's pretty important. But also, we have to deal with local variable generation and lookup, both in type checking and in code gen. This is broken. Why are we just pointing to the same symbol? Hello? I screwed up environment C a little bit, didn't I? Huh. I see, so I'm calling it twice in the same thing. So I'm gonna have to do this. Hooray for C. That right there. That right there. That's much better. Cyber Patty says, that is the endless struggle of making a language, creating meaningful errors, lol. You are correct. Grammar says, CodeGen must also handle stack and stack frame for scopes and inner function calls. Grammar, I know. That's literally what we're working on. Yes. Yes, Grammar. We have our global environment, and then we're going to have environments within it, right, that contain other scopes. So then what we're going to do in CodeGen is have our CodeGen context and a separate data structure get built with a similar thing. Or we will assign how this has a symbol here. Since in parsing we only ever use the first child, in CodeGen we could always just add a child to this variable definition, which contains the integer of the base pointer offset or the symbol of the register that it's stored within. So we could always handle CodeGen either with its own data structure or whatever. Cyberpatty says, I'm so in the process of making them better. Lamau, that's right. Eternal Wildfox says, true, Cyberpatty. I am just in the compiler scene for 3 days. That's right. Eternal Wildfox says, I built a math expression engine. And then he says, weird, the sound was gone again, needed to reload. That is very odd. Hopefully everyone can still hear me. Cyberpatty says, that is so cool. Is it like an expression transformer or what does it do? I don't mean to answer for Eternal. He made a calculator with operator precedence. So it accepts numbers and grouped expressions with parentheses. So we basically made a Pratt parser and an evaluator for that, what it parses, using a visitor pattern and stuff like that in PHP, which is impressive. Grammar says, in future, I will make my error messages much better. Like I will use Levenstein distance to find out the best token to suggest. Isn't the Levenstein distance like the closest in a group of nodes to a given point or something? Am I wrong? Or is it like the average of the... I don't even remember. I don't remember. I'm not going to talk out my ass. We'll just look. Levenstein. Fun. Oh, yeah. Yeah, so it's how close two strings are to being equivalent. And then, so for example, Cyberpatty says, I might yoink that idea. So that's actually something I've already looked at a lot into, because when you mistype like binding for binding, it says, did you mean binding? Look, it does it already. It uses the Levenstein distance, I'm pretty sure, as well, if you look at the internals of GCC. But it literally says, did you mean binding? So it does the same Levenstein distance to say, I think you meant this. It's bound in the types environment, so you probably meant this. It's very cool. Eternal Wildfox says yoink. Oh, he doesn't know what it means. Okay, so yoink is like stealing, but like in a coy way. So like a child, if it's trying to steal a cookie out of the cookie jar, that would be like yoinking a cookie out of the cookie jar, if that helps you, Eternal Wildfox. So yoink would be like, yoink, I'm stealing that. And it's also a sound effect you would make if you take something like out of somebody's hands. So if somebody's eating a sandwich and you're their friend or something and you run up and take it out of their hands and take a bite, you'd go yoink and then take a bite, if that makes sense. Hopefully that helps, Eternal Wildfox. I hate when I accidentally use words that nobody understands. Grammar says, yeah, and I will learn how to implement the algorithmen. I like algorithmen. That's kind of funny. Algorilla? I have never implemented it. Nice. Levenstein distance, I have not implemented either. But I've watched many video on it, honestly. I think I watched like 2 different video essays on the Levenstein distance and how it's useful and stuff. Because I'm a big nerd. So we can now print everything and store children within our parent context. Algorithm person. Auto completion. Lamau. Grammar to parser boy corrects it. Cyber Patty says algorithm person. Grammar says auto completion. Lol. I really like auto completion. Just the the evolution from algorithman, algorithm person, auto completion. It's such a good one. So we have types, blah, variables, blah, binary operators, blah, functions, none. Oh, we do. We have the symbol foo, which is a function. So it just says it's a function. I kind of like that. So then types, variables, functions, types. So then if I defined a function within this function, ideally it would show up in the right spot. And this is not the final function syntax. It's going to look more like lambdas, where we're going to have like bar is a function equal to, it returns an integer with an integer, the body, right? It's going to look more like this in the future. But for now, it doesn't. It looks like this, just because this is how we wrote the parser weeks ago, or a week ago. And we haven't updated it yet, because we're lazy. Yes, save. Perfect. So now, in the global scope, we have the foo function, but in the foo scope, right, we have the x variable and the bar function. Cyber Patty says, pog. Yes, give me that pog. You gotta say it like Soding, right? Soding. Cyber Patty says, let's not say, did you mean binding? Just change that shit in the background without informing the user and just work. Poggies. With a... Poggies is funny. Grammar 2 Parser Boy says, could be really hurting for the user with a missing U. That's pretty funny. So, what I've never seen is I've never compiled a program and have the compiler ask me a question. Function definition requires body following return type. Ooh, it does. There we go. That's better. So now we get a function with a function within it. Beautiful stuff. So Cyber Patty, I've never had a compiler ask me a question. So I didn't write it down in this, I wrote it down in my other org journal. But effectively, my dad had the idea when I was talking to him. He's like, what if it just asked you what to do? And I was like, wait, that's actually a good idea. Shit. It was like, that's really smart. So you're right. If we type like integer, we should just ask the user, did you mean integer? And if they press Y, then just fix it and continue on. Cyber Patty, are you stupid? Error. Lamau. No matter what you press, it just says error after you, are you stupid? That's really funny. No, but it's true. I want the compiler to ask, like, did you mean integer? Then you just press Y, like how Linux works. Like, and then you just press Y and it'll fix it for you and continue parsing. And I want to do the same thing. Grammar says could be really interesting for tooling. Tooling. Like testing. So like tools surrounding the development of the program. So if we're trying to develop, or if we're trying to run a test and then it asks a question, we'd have to write to standard input in the test and stuff. That's true. So what we'd probably have is a compiler flag that turns that off and just says error if it doesn't work, or always say yes and do the fix. So then we could just have it ask, or default no, default yes. That way the user gets to pick when they're compiling how it would work. I timed mine Lexer parser and interpreter. It ran in 0.000126 seconds. That's impressive. That's very impressive. What's it parsing in lexing though? Is that like a megabyte of lexing and parsing? Or is it like 3 characters, right? Because I can parse instantly if I'm not parsing anything, right? It's pretty easy. You'll just return right away. And then Grammar to Parser Boy asks, is this one run or an average? That's a great question. Man, I remember when I was doing performance, trying to figure out an efficient mem copy I could use in Lenser OS, which is still, by the way, I was very dumb back then. I did not know how to write efficient code. Don't look at it, please. Cyberpatty says, that's better than the 14 seconds to compile torth with torth.torth. Lamau. Self-hosting always takes a while. Cyberpatty says, fuck performance, I go get coffee. That's right. That's so funny. Woo! All right, so let's figure out how we would actually parse the different function. Also, this should be like within a parse function, left denotation function, but it's fine. So null denotations, left denotations. Okay, so with this left denotation, I basically would like to add a custom syntax for a null denotation. A function should be a null denotation. Okay. So if the current symbol, oh, I just did that wrong. It's like, why did that not work? Why did that not work? And if that equals 0, so function return type, function parameter list, and function, I don't need function at the beginning of each of these. Okay, so return type, parameter list, and then body. Grammar to Parser Boy says, my compiler runs about 2/3 of a second. Nice. We'd have to create some standard for what we're compiling or what we're lexing and parsing, right? Eternal says, indeed, to time it even better with a long math statement. Yeah. Eternal Wild Fox says, but that was one run, Grammar to Parser Boy. Bobby. I like it. We got Bobby. Return type parameter list and Bobby. I like it. Bobby! Looks good enough to me. So, to look for the return type, we do this weird... So this is a named function. We're going for an unnamed function. This is the parameter list, and this is the type. No, that's still part of the parameter list. So then parse return type. Okay. Give me these two things. And then I will work on them up here. So first, we're going to be looking for a parameter list, which means that we have to expect the left. We're just going to copy so it's a bit easier. We need to expect the opening paren so that we lex past it. And say if expected.found or expected.done. Then this is an error syntax. But we can't do that. Parameter list required within Lambda definition or whatever. Grammar says you need more runs to get a more real result. Absolutely. Grammar also says, my math engine has a module system with default module with functions like for physical calculations. What? You lost me there, Grammar. Yeah, what? So we're basically doing that, but here. So this is the return type, and it gets stored in this function, return type node. So all we have to do is put this after the next node add child, which is this. Eternal says, I am also lost now. Grammar says 2/3 second equals lexing, parsing, macro expansion, IR transformation, and MSIL assembly generation. Nice. What is MSIL? Machine, I don't even know. Machine source instruction language? Machine, I don't even know. Okay, so we get the return type. But we don't have to expect this. So this is the return type. This begins the parameter list, which is why I'm a bit confused. So we get that parameter list. CyberPatty says machine L. I really like the machine L. That's definitely what it stands for, right? MSIL. Machine L. That's it. We got it, boys. Pack up. Grammar says his language is written in C# in response to Eternal asking him what language it is written in. Well, I don't think that's too bad. We got to get the Bobby. Yep, that's pretty much it. Alrighty, that seemed to work. So now we just have to actually try it. Bar is a function, returns an integer. Not quite. Reassignment of a variable that has not been declared. That is fair. That is how our language works. We have to do this. So we need to add function as an acceptable type. Here. We're not going to worry about what size it is yet. We're just going to put 0 for now. No, let's just do 8. I don't know. Why not? Pretty good. If I do say so myself. Eternal says, I wanna also write a lexer, ein lexer / parser in C++ and maybe also C#. Grammar says compiler has plugin support, but it slows the compiler down. At Eternal Wildfox, C# is a great language for writing compilers. It can be pretty good. It's pretty ergonomic. Eternal says C++ also. Hee hee hee. CyberPatty says, I still do not have any other types other than the basic ones, int, string, pointer, etc. And then Grammar, he pulls his large hog from his pants and says, I support all .NET types. CyberPatty says, that's one of the first things I want to support after self-hosting works. Nice. My type system is sheet. Hey, mine's not great either, but you make it work. You make it work. See, exited abnormally with code 5. Ain't that wonderful? Why would it do that? Compilation exited abnormally with code 5. That's in Windows an access denied error. Try and see anything going wrong. It's not happening here. So it's got to be in what we just did when we were parsing. Or something. So it's got to be, yeah. So we allocate the function body, we add the function body to the working result. We set the first expression as our working result, because that's what we want to write into. And we go handle that with the defun operator. Issues arise. Issues arise. It's going to be a little different than defun. Right? And it's going to be different because we need to parse that closing array thing after we parse this to make sure it's a valid lambda. Probably. In any case, if done or found, what we would like to say, ideally if we're done, we should say there's an error and we expect this, but it doesn't matter. So we're just going to say if this, yeah, done or found, why not? Then we're going to expect more things, which would be a closing bracket. Otherwise, error prep and return. Ooh boy. Grammar says, my next step is working on checking of implicit typecasts. May I use a type map to avoid huge conditions? Nice. Eternal says, my next step is allowing algebra, then I am one step closer into writing statements. Yeah. Very cool. Error prep, error syntax. Expected closing square bracket or lambda definition or whatever. Following lambda body definition. Sure. Why not that? Oh boy. Okay, some errors. Otherwise, working result, we move on. It seems like this would work, but it does not. And I'm not exactly sure why. Let's try and stop here. And see what happens. Well, we get there. So we have a function with x and an integer and an integer. So let's do static count equals 0, count's greater than 1, exit with count. Why not? Exited abnormally still, so we don't get back here. So it's not a nested it's not a nested lambda, I see. What am I trying to compile as well? I should probably worry about that. So in foo is a function. So we can get foo as a function. And everything is working just fine. So let's go down to defun. Oh, maybe I changed the wrong one. So we have defun. Yeah, isn't this the wrong one? I think I literally just did it backwards. It still didn't work, but I did do it backwards before. Because here is where we are dealing with defun. So we should say defun. And here's where we're dealing with lambdas, so we should say lambdas. A first time chat from a viewer, CodePhiliac says, I see lens in lambda, I click. That's so awesome, I'm glad we could get you here. We're currently working on parsing lambda definitions. So parse this parameter list, do things. Parse the function body. Maybe this is where the not popping the context is creating some issues. Because let's see if we can just do something very simple. And say, just give me something like this. This should just be a lambda. And that doesn't work. So the lambda itself is broken in some way. Parsing the function body. We set the context operator. CyberPatty has a great question. Hey, CodePhiliac follows. Thank you so much for the follow, CodePhiliac. You are part of our affiliate initial count, because I'm technically at 49 out of 50 followers for Twitch. So you're probably just the 50th. Thank you, CodePhiliac. CyberPatty says, what information does each token of the language contain? Token. That. A beginning and an end. It's a complicated one. So you have like your source code, right? And then you'll have like X as an integer. So token, if it pointed to X here, beginning would be here and end would be here. But if it pointed to integer, beginning would be here, end would be here, etc. Linked lists in 2022, Kappa. Absolutely linked lists. This isn't a linked list though, in any way. But absolutely linked lists in 2022, why not? They're useful, my guy. This is so interesting. So if we are here, I'm kind of curious how many we're able to do. So let's just see, stop right away. It didn't. Excuse me? There it goes. Okay, so that still doesn't work. Interesting. Very interesting. CodePhiliac says, is that an Emacs? Pog. It is Emacs. It is Emacs, absolutely. CodePhiliac says, yes it is. Something tipped him off. Man, we have not made a lot of progress today, I don't feel like, but at least we're beginning some things. Yeah, we got some big issues. Parse lambda. So if we never do this, we still run into the issues. You see this? Still get exited abnormally with code 5. So I'm kind of suspicious that we screwed something up. CyberPetty says, I tried it once, got diarrhea, had to try it again, now it's usable. Codephiliac says progress is progress, except when you're being measured in sprint points, then it just sucks. Lamau. Oof, that's true, that would suck. So we get the return type, we get the parameter lists. I don't see an issue with any of this. That makes sense. Much better. Now the function itself gets its parameter list, return type, and body. And then we parse into the body going forward. Still exited abnormally with code 5. But we can get here. No. So this doesn't even have to do with parsing. What else did we change? What else did we change? So while there are bindings, there should be nodes. So I guess we could literally we handle unknown types and nodes, but we still dereference it. So we should say if not node, return null. Okay, so not a null dereference from there. It's a null dereference from somewhere. We'll figure it out. Parser.c. Did I exit after continue? I may have tried that. Did I put it in the wrong spot? That'd be silly if I did. Yeah, see, exits before the continue. It's still, we still get code 5 and not 1. So we're never here. We're here? Gotta check. What about a little higher? Do we ever parse this? No. So, look, I still had the 0 there. Silly me. So now we can actually check. Codephiliac says, isn't 0 considered as false in C? Bruh. Eternal Wild Fox says, C# changed from C# 9. You don't have to write a main function. I don't see how that's relevant, but that is interesting, I guess. Yeah, still exited with code 5. Still does not work. And code 5 refers to an access denied error. Why are we denied access? Where are we denied access? How are we denied access? Eternal Wild Fox says, oh lol, I was looking at C# again. I see, that's right, you were looking into it. C# is just a scripting language after all, says CyberPatty. Lamau. So this should just parse a function and then nothing. So does it have to do with the fact that we have nothing? It doesn't. Does it have to do with this lambda? It very much seems like it had to do with that lambda. There's definitely something here breaking things. Can we do defun without the lambda? We can. So it's literally just our lambda syntax. Codephiliac says Kappa. Emotional damage, Keck W. Cyber Patty, you stupid. You named Steve? Who's Steve? Integer. So we get a type name. I don't think that's too insane. Just checking that I get this before I go crazy. Function return type. What? I don't think I ever, yeah, that would make sense. And it exited abnormally with code 5. Interesting. Symbol, value, symbol is all we're comparing with, right? I see, then at the bottom we're doing lambda and stuff. So we're comparing to 0, close that. So that should be this. I don't see why that's an issue. Alrighty. So context result, we do set that, right? We do, we set it to our function first expression. Ah, that's a bit of a problem. So we had an issue there where we're updating working result before it should be used. And our function that we're actually setting. So here, let's see if we can do this. Ter function, we'll call it a lambda, equals, it's going to just equal the working result, right? So now we can say lambda, and not have to worry about that. So it's a little more clear what goes on. Okay. And issues arise. CyberPatty says not even self-hosting Corth with Cython implemented in Corth. Kappa. That's a lot of meta. So that's a meta circular evaluator, if you ask me. So we say context operator. Okay, it's not, don't think it has to do with the context being wrong, at least in this case. This is so interesting. Something is very broken, and it's probably very obvious to someone watching the VOD or something right now. What is broken? But I don't know what is broken. We're not even exiting 1 here, you know what I mean? Which you'd think we would do rather quickly. Huh. I'm not sure how this happens. The first thing we parse should be that. Ah, I know what it is now. That's not a delimiter, you silly boy. Let's just add some more delimiters in. Hey, look, we're now exiting 1. Hey, look, we're now getting an integer function return type. Hey, look, we still exit 5. Damn. Close. Close. The whole internet and their mom sees the bug. CyberPatty says, see, told you. We just weren't lexing properly. But now we are, and it still doesn't work, so we get to figure that out. So this, what are we gonna do here? Let's try exiting. So we never get here. That's telling. Ah, that will not work. How would that ever work? We don't have children yet. So we need the parameter list. Yeah. Hey, look, we exited one. Ooh, we did that with no debugger. We don't need no... Oh, did I just close Emacs? Oh no, I just alt-tabbed on accident. Lamel. I was like, uh-oh. We don't need a debugger. Nah, nah. So now we have a function, foo, which is a function. We also have symbol function bound to function. Oh, that's types. I was like, wait, that's not a good variable, but that's not a variable. Symbol z is an integer. So, a pog. We got a pog bones from Cyber Patty. So even if we have stuff before and after it, it breaks. So something here breaks. Is it the negative? Not the negative. Something here is very broken. That's not good. To do. Something breaks here. Sad face. So if we don't do a function call, does it work? It does not. But if we don't do it, it sure does work. Pretty good, pretty good. So now we have foo, which is a function which contains a variable z and an integer. Oh no, 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 no. I'm wrong. This is not a children. So in the global scope, we have the foo function. Cyber Patty says solution, not just do it. You're welcome. Just do not do it. Yeah, simple. Done. It works. I don't know what broke, truthfully. Just binary operator parsing in general broke. It's pretty interesting. But lambdas work. So now we can have bar, a variable, in a scope, which is a function. Yes. And then we just need to say, when we get a variable assignment to a function, we probably should define that. F numbers, lambdas work. That's right. Sometimes like when parsing, it's like that. You just have to get one thing done at a time. Wow, we broke something heavily. So we can no longer do 2 times 3. Binary operator parsing is done for. What happened there? I mean, we just have an if and a continue. There's not really any fancy new branch to take. And the idea would be we get an integer, and then what? Cyber Patty says just implement operators with lambdas. Lamau. That's actually what we're going to do. We're going to have users able to define their own operators. So we're going to be able to do like define operator or something like that. Or defop or I don't know. But they're going to be able to define like underscore, and then they could say it takes in 2 arguments. And then these become the left and the right side of the binary operator. And then we're going to have the function body, of course. But we could absolutely have this be like an operator. like this. Cyber Patty says, ooh, nice. Very nice. Also, I'm not sure if I caught it, but right after Codephiliac followed, Cyber Patty followed. Thank you so much for the follows, everybody. I very much appreciate it. We are definitely going to be Twitch affiliates by tomorrow. That's so exciting. But yeah. To do would be this syntax. To do, support operator, redefinition. Perfect. Yes, yes. So why can't we do 2 times 3? We parse an integer, and then we go to the bottom of this else, in which case we parse a binary infix operator. In which case, so then when we see lambda again, so my current working theory is that we're not actually popping the stack when we need to, right? Like we need to do something like this. Does that make sense? It doesn't make sense because we just return, and this is a stack variable. So returning after setting a stack variable won't do anything. So the context will be the global context, but this context should be the parent context when we return. But we shouldn't even actually get into a stack continuation, should we? I don't think we should. So maybe it's not that. Maybe my instinct is incorrect. Maybe it's something else that we can track down easy. We were just able to do this, I swear. So we can parse an integer, in which case we end up here, right? And then we end up here, going, okay, look ahead for a binary infix operator. If we find one, then continue. Okay. So print node working results. Why not? And we still get nothing. We're gonna have to exit one, try and see some output. Still exited with 116. So if we're not even getting here, that's a little worrying. So parsing a binary infix operator. Let's see. What could be the issue? So the context we pass should be our current context. That should be fine. So then we get the global context to look for the operator. And if we get it, we say, okay, we looked ahead for an operator and we found it. Set our working result and continue again. Yes, so it says result equals a new result with the copied left-hand side of the binary operator. And that's either working result or result. So we either take our entire node that we're working on and put it on the left-hand side, or we take the current node that we just parsed, like a number, and put that on the left-hand side. Okay. Or the node itself, like a binary operator with higher precedence, I believe. And this exits with code 116. So do we ever actually get anywhere here? We do. Exited abnormally with code 1. So when we do found, should say else exit 1, and it doesn't work. So we tend to continue. Is that what's happening? Nothing printed out, I'm sure, because we fail. So let's just exit and test that. Interesting. Isn't that interesting? So here we get yeah, we create a new node and then don't use it. But we use the symbol. So we can't node free. Is that really it? It's not. Free operator symbol. What is this? It's what we were node freeing before. So if we use the symbol, we don't want to free the actual symbol, but we do want to free the node that we allocate. Like operator value, we do the same thing because we allocate a node. So operator symbol we want to free unless we actually use it, but I don't think we use it other than here and here. An environment get will never copy the ID it's given. Oh, we're freeing it twice. Somebody kill me. Lamau. Continuing. That was all because we were freeing something twice. That's embarrassing. Lamau. In any case, it works. We're back to parsing. Also, was that correct? Hey, and we're parsing with operator precedence. Because it works. Ain't that beautiful? Ain't that beautiful? So now we can have a function definition, which is unnamed. What? This is a function, but it says none. So we definitely changed something, or we didn't set the type. That's probably likely. Lambda type equals function. Cyberpatty says, it's lovely to see someone else having memory problems too. I know. Watching people code in Python or like Java, they never have to deal with like just the program crashing over and over from some random memory error. They just never deal with it. And it's like they're living a different life than me. But it is absolutely, I love sharing hardship. It lets people really see what it's like, right? Because this is what it's like to develop C programs. This is like, you know what I mean? This is just how C development goes. Sometimes you write some new code and you screwed up, so it's gonna show, which is okay. So we have a global type function, which is a function. Some operators, sure, why not? And then we have a nested scope with z as a variable within that scope. That's perfect. So now if we do foo, that should be an I. I was like, wait, I screwed that up. Perfect. It's working now. It's working. So now we have, okay. Yes. So now we have a global function foo. We have our first environment. Man, I really got to print these out a little better. We have our first environment, which is z, our unnamed function. Then we have our second environment, of our second global environment, I should say. And then this is foo. And within foo, we have bar, which is a function, and that has an environment nested within that foo function. So foo environment is here. Yes, here. And then this is the bar environment, the bar lambda environment. So you can see y is passed here. Beautiful. And even if we do this, everything should be fine. Look, we even now hit our code gen to do. Local variable declaration. CyberPatty says, boys, it's time to re-implement operators. Yeah, that's awesome. They broken anyways. Mal. I think operators are always something that's broken. Ooh, we're getting some issues towards the end of the program. But it's fine. You have a function, variable declaration, function with a variable declaration to a function. Beautiful stuff right there. Look at that. That initialized value. And then we actually don't see x. X does not get picked up here. That's no good. In case you didn't notice, that's no good. So this function, oh, that's not the function body. But the function body should contain y, should it not? We're not parsing variable accesses, I don't think. So if a symbol is not a lambda, it's not a function definition, which I don't really know what the difference is at this point. I can probably just get rid of this, but it's fine. I guess the difference is the symbol and setting it in the environment, right? This thing right here. So we have to do a to-do, a bit of a to-do in Lambda, and say, alrighty, we've parsed pretty much what looks to be a function, and we would like to say to generate name or something for Lambda to be bound under. And then, interestingly enough, I don't know if we actually need that unless it's a Lambda because it's a variable declaration. We should just be able to handle that like regular. So I'll say to-do / fix me. Do I need to bind function in environment? Perfect. Bobby, please. My function Bobby. Yes, we parse that Bobby. Bobby, give me your Bobby. So funny. Perfect, perfect. All right. That's not bad. It's working. I think that's all that matters. It's not working perfectly because we don't do variable accesses, but that's fine. So if it's not a variable declaration and it's not this, and it's not a function call, hey, look, there's the to-do. Check if it's a variable access. Dope. So should we just have like a symbol, foo, and that's a variable access in CodeGen? Or should we have an actual variable access node? I feel like we should have a variable access node. We'd say working result is equal to, I don't know. Variable access. So I'd like to say if the symbol is a defined variable, then we're able to access it. So we should parse, say, while context effectively. Context equals context parent. And if we happen to get the variable along the way, that would be great. And into result. I don't think that's right. We're gonna need some node pointer result. Node pointer, what is this? So this is a variable. Sure, why not? And then, whoops, free variable. Okie doke, okie doke. So we would like to get the environment. And if we do find the variable break, say if not context, probably error at unknown token. Otherwise, because if context is null, that means we got to the end. But context may be null, and we break. So yeah, we're fine. Don't listen to me. Don't listen to me. So we would like to create a variable access. For now, let's do reassignment initialized or whatever I had before. I don't use this anymore. So variable access node. And the variable access node could either contain the symbol, so we could have like a node with variable name, or we could have a node with a child, which is a symbol, which is the variable name. Let's just have the node keep the variable name for now, right? Why not? I don't think that's a big deal. So then we can just say working result is equal to variable declaration initialized with its value symbol set to variable value symbol. And we'll duplicate that for ourselves. All right, let's take a look now. We get a variable declaration initialized. I think that works. So now we can just go rename this to access and change it. Because an initialized variable declaration is actually just going to end up as a reassignment at the beginning of the program. Right? Contains symbol value. Contains variable symbol in value. So that's good enough for me. And this will tell us where we need to go change things. So we're not comparing variable accesses, hopefully. And how are we looking? That's looking much better. We can probably print them like this. And awesome. I can't believe I've been streaming 4 hours. I gotta go. I'm losing my voice. Hey, Pog. That's not right. That's not right at all. Variable access integer. How did that end up happening? It says variable access integer, and it says that twice. What? Okay, we're gonna simplify this a little bit. Parse just the math. Wonderful. Cyber Patty says, you have certainly inspired me to also stream Torth Dev someday. That's awesome. I'm really glad. Always love to see new streamers. variable access should say z, not integer. This doesn't make sense. Ah, I get it now. That's much better. So now we can access variables z. Perfect. And if I did that here, it breaks. Ah. I hate when it breaks. Why did it break? CyberPatty says, I've thought about that for a while, but I'd rather not show my face. It seems to be a norm that you have to show face, but I guess us devs are different. What do you mean a norm? Like, why? Just because you stream doesn't mean you have to do what other people do, right? Do whatever you want. If you don't want to show your face, don't show your face. Wear a mask if you want to take video. You know what I mean? Like, there's so many options. I wouldn't worry about it too hard. CyberPatty says, I know. I still wonder where we're printing this node. Right there. That's better. So we can have a function with a variable access x. Not a big deal. This breaks things. Turn error prep. Oh, that's not going to work. Error syntax. Unknown token. Like, we just don't know what to do. Print token. Current token. Sure. I guess we could print node symbol. Here, we'll do this. Unknown symbol. Why not? And this will say symbol. Well, we'll do node text. Or symbol. What's the issue? Return with no value. Yeah, that would be an issue. Exited abnormally with code 1. Hey, that means we could not parse it. And it says compilation exited abnormally with code 1. Interesting, interesting. How far did we get? So we parsed a variable access y. So we got all the way to here. CyberPatty says, well, I guess our own compilers are not meta either, so why should our streams be? Because who codes for fun, for fuck's sake? Us, apparently. So we get the symbol X. Why did we print that out? If not context. So this means the variable wasn't found in any environment. So we're looking for symbol X. It's in this environment. So we're trying to return X, and it's bound within the environment. And our parser says, no, it's not. I don't know how to deal with this. So this unknown symbol is X. It says it doesn't know how to deal with just that. So what's our current context? We should be updating it here like this, right? So our current context while parsing the variable access should be the one within the bar, right? And then, no, yeah. We'll have the bar variable declaration, and this function will create its own scope. But then after this, we'll be in the scope of this function, which is foo. So we need the foo function scope. in defun, what would be the issue? What would be the issue? So maybe we're not returning? That shouldn't be a big issue, though. Let's try it. Let's try it. Should we pop parser context here? Let's try it. Still no. Symbol X. Okay. So instead of doing this, we can go to our symbol error message and print the environment, the parse context, right? Where we are searching. I don't think I have original context here. So we are searching that environment that we print out. So we have the variable y. What? Types, variables, functions, types, variables, functions. So we get here and have y. Then we get here and have this whole thing. Interesting, interesting, interesting. So somehow we have the top level context and not the parent, which is very interesting. Cyber Patty says, little solding session. How about that? How about that? So this is a single environment with a nested environment, but we shouldn't be in this environment. We should be in this one down here. It's on its head. This is a little confusing, right? Because we should be within a context thanks to this. Create. Right? So we should all of a sudden be within a context. Oh boy. So as you can see, that context that we newly created in defun has nothing within it. Which makes sense because we just created it, right? So we want to print it after the parameter has been bound. There we go. So you can see that this has the integer x bound, but then it says no good. So x is being bound while we are parsing our function body. And x is bound in the current context for defun. So then, within defun, I mean, I'm not sure what the what's changing here, to be honest. Because I gotta stop streaming. I've been streaming for so long. I really gotta go. Okay, so parse context print. We got symbol X and then just an error. We didn't actually get anything printed out, which I find interesting because maybe that means we're never actually leaving this one. I don't even know at this point. Don't at me. Nope, still didn't get there. Interesting, interesting, interesting. Symbol X. So we parse a lambda, and if we handle the stack, we should pop it. That is what should happen. I'm pretty sure. But we are getting symbol x not bound for some unknown reason. Right here. And that means context is not, which means that variable symbol is not a variable set in any of these. So we're going to take a little look-see at this, right? So it looks like, obviously, we wouldn't get the variable x, only y is defined. But the problem is, we should have a parent, which is set. See, so this is the parent here, and the parent has x, which is an integer. So the idea in this loop would be if x, right, we were looking for x into variable. So, print node symbol, right? So we have a symbol y. So we should just look and find it right here, should we not? What is going on? Got symbol. I'm just curious if we actually, we can't do that. We do got symbol. Okay, so then if I do this, should ideally, yep, we get it in the first one. Context is never updated. So we got symbol. And in doing so, context should not be null. And it's not. Context is not null. And then we, what? So context being not null should matter. See, context is null here. And how did that happen? So we're looking for the symbol x. Ah, look, it's in front of me the whole time. This can be a continuation, which means that we have to restore our state. It's not a null denotation anymore. Still null context, but I don't think it was as much of an issue. Yeah, we no longer get unknown symbol, and we now get our variable access x. Look at us, we did it. We actually did it. Haug. How about that? How about that? This is very cool. So we can parse a function with a variable access. Like this. Okie dokie. That makes sense to me. Now, did we break everything? We didn't break everything. We did break something, though. Rutrow. Oh, if I'd have Soding Pog. Lamau. We need them premium emotes. So we have a variable access x, followed by a variable access. So why is this in the wrong thing? This is bad. You are incorrect. This should be here. This should be indented. So it's still broken. So, interestingly enough, we are not parsing correctly. So if I don't do these, I'm just curious, what the hell is going to happen? Same thing. So why is this happening? How are we exiting? Lambdas don't exit, they continue. So we continue, given it's a lambda, right? So returning when it's not an error. Looks pretty legit. Tap out boop. Imagine returning from Lambda in 2022. Okay, so we are still doing precedence parsing, that's working, but we're just doing some very bad naughty things where we are exiting from something too early. And I'm not sure how this works, because our working result is being updated twice in a row, basically. What? Right? So this says parse context print. Are we never actually here? We should definitely be here. We say operator equals fun call and then continue. Right? So we should say operator equals defun and continue. That's what we do. So in this case, you're telling me I never get to defun down here. Just kind of curious. We should see a lot of those. But we're not getting any, which is worrying because I don't know how we get here. So we get here through our working result update. So if we go to defun, so see that our working result is set to the first expression, and then we continue, so then this is parsed, a variable declaration. Right? In which case, we try and parse an initialization, otherwise we end up looking ahead for a binary infix operator. And then if we are in the global context, or not, yeah, if we're in the global context, just return the expression. Otherwise, continue handling within the current scope. Because node pointer operator equals context operator. Yes. So this operator, context operator, is either lambda, defun, or whatever. And apparently it's never defun, right? Is it ever lambda? We see lambda once. So, interestingly enough, our lambda function continues once we get here. But then we should see lambda go straight into defun. But it doesn't. We just get this error. So how could that happen? Ideally, defun is the parent context. So defun being the parent of lambda means that when we continue here, see, we are breaking here, which puts us right at the top of the while loop. Right? No, breaking means we return. Isn't that what break means? Because we're not in a while loop here. Yeah. So that breaks out of the top level while loop. I don't think that's right. I do not think that's right. Because we don't want to return no matter what. We want to jump back up here like this. So when we break in defun, should truthfully say if not parent, break. Otherwise, context is equal to the parent and continue. Does that make sense? And then we should probably say working result equals context result or something, right? Nope, not quite. Still just lambda. Oh, well, that would make sense because I did it in the wrong order. So if context parent is null, Rohan says lurk, lurk. Hey! Thank you everybody so much for watching. I've been streaming nearly 4.5 hours. I really gotta stand up and do some stretches, get out today before I just spend it all on stream. But definitely go down below and check out the YouTube link to see any previous broadcasts if you're interested in that. There's also the Discord if you would like to get announcements every time I go live. I make announcements every time I go live on this Discord. Hey, Cyber Patty, how's it going? Heyo. But yeah, we all have a lot of fun. We're friends and we all talk, share our progress with each other. I really recommend it. Other than that, I also recommend hitting that donate button down below. If you have the extra dollars, I greatly appreciate any and all donations that come in. If you leave an appropriate message, I will read it. And if you leave a username, I'll attribute it to you. We have a question. Does comma do something else in your language than separate params and function like structures? Not yet, but that's all it does. I don't know what else should comma do? Why do you ask, Cyber Patty? Exited with code 5. Wonderful. So context result will equal in defun will equal the first expression. So we would then like to say this whole thing where we say context equals context parent. Then we could set the result next child to a new node. So maybe we just do this. Cyber Patty says, I mean, if it does not, I like the idea of making it optional. Next up, the comma-only programming language. That is funny, Lamau. We're starting to work. I think this is starting to work. Hey, expected closing square bracket. Okay. So math. Let's make sure that I didn't write the code wrong. Where is it expecting? Where is it expecting a closing bracket? We have lambda. So it's probably right here right away, right? And it says invalid syntax. Expected closing square bracket. Okay, so this is going to need to be in an else because of our new control flow, where this falls through. So if not, so if that's not found, that should be that. Hey, look, we have a memory error. Cyber Patty says, words separated by just white spaces seem more appropriate for stack-based languages, IMO. This isn't a stack-based language. Cyberpatty says, that's why to me the commas seem a little oddballs. I see. This isn't a stack-based language. It's just a language. A statically typed language. So this doesn't work. Because in Lambda, we set result, context result, the same way we do there. Cyberpatty says, is it not? Oops, lol, my bad. It's all good. There's no problems. I just want to... This was like, wait, this is not that. So, why? So why? So if we find the end of the body, then look for the end of the lambda. And if the lambda is at the top level, return it. Otherwise, update to your parent context, which will guaranteed not be null. And then we can say the result is the next child node allocate. Here's the thing. If the parent's parent, right? If we have global scope here, that doesn't make sense to continue and do this. It only makes sense to continue and do this if we actually have a defun or a lambda. So we're not going to use this little continuation thing. We're going to say if not context parent. Then what would we like to do? So if context parent existed, we were within a lambda, but that lambda was within the global context. When we pop, there's nothing more to do, which is what this checks for. So this checks for the context parent being non-null. So if it is non-null, then that means we are returning. Cyberpatty says, RTFM, you stupid? Lens probably. Ryan says, nah, I do not even know what a stack-based language is. You're fine. Cyberpatty says, stack-based language is like Torth, Kappa. Torth is like Porth, which is like fourth. Which is like Korth. So our issue becomes, we kind of need to do, let's see, we kind of need to, I don't know. So if we are in the global context and we parsed a lambda, just return it. Otherwise, continue on and say the next child of the context result See, I'm confused because this thing needs to, like, we need to do this whole comparison again. So this would have to be like handle stack operator, but we can't move this into a function because of its return, like its control flow handling, which sucks. So what we'd like to do is so if we have none expression, can we like just zoom right to a stack continuation again? Because the problem is when a lambda returns to, well, this should still work. We just have to set context result more often. So in main, well, in parse program, I guess, then, every time we parse an expression, we should set the context result equal to expression, because expression is the last child in the program. Exited with code 5. Wonderful. So to do, I just want to make sure I did this. I don't want to lose track of what I changed in here. So the result is equal to expression, which means that the result next child should equal a new node. This should be entirely fine, right? I think it should be fine. And we would like to set the context result next child to a new node, the working result to that new node, and then the context result to that new node. Yes, we set these two to the same value. That seems like it'd be fine, but apparently it is not. So context result should equal working result on many an occasion. We should do this often. Like here, maybe. I don't know. Where do we actually hit every time? Lambda says no. So we look for an operator. So the idea, what I'm trying to solve here, is that we have this global scope, which we can't see right now. We have this global scope, and I'm worried that context result is null here when we're trying to return. So context result, right? Still exited abnormally with code 5. Type some Lisp there. I googled Torth programming language and some other dude's repo was shown before mine, but the other repo was dead, Lamau. That's common if you don't check your name first. GitHub has so many programs. You gotta make sure to choose an original one or they're like, nah. So it doesn't seem to be that. Hey, look, it was that. We fixed it. So we have defun returning to a null context. So we were literally just working on the lambda instead of defun. That's why our changes probably weren't working. Wonderful. Okay, so we have to handle if context is null now, right? So if not context, that can't happen. But if the parent is null, that can happen. In which case, it won't have a result. I don't even know. Again, working in the wrong area. Classic. Classic me. Well, this is interesting. Lots of things happened. And things look broken. And now it says it can't type check because this binary operator adding together a function and 1 does not work. Yeah, that would make sense. So 2 times 3 plus 1. That didn't work because we tried to overwrite our entire result. I presume. Rohan says, easy fix. Just set the result to 1. Easy. Yeah. Done. Boom. Done. Easy peasy lemon squeezy. Cyber Patty says, the repo was younger than mine, so I guess I killed an imposter? I even remember checking that there was no repo for that name. RIP. They got that search engine optimization down, I guess. So if it can't equal result, what can it equal? Because result will be our program, I presume, is what our issue is. So our actual program, no, result will be our expression. So then we set expression next child. To a whole bunch of issues. Okay. Cyber Patty said, they just famous. Yeah. They're just famous. I don't know. Hey, look, we're actually parsing correctly. Nearly. Is this right? Yes, we're parsing correctly. The foo function has a body with a variable declaration of bar to a function, and then there's a variable access after that variable declaration. But the problem is then we get some issues next. So how do we fix these next issues? They only arise because interesting. Because interesting. I don't know. So how do I set context result to always be equal to... So the global context result should just be equal to the global context result. I don't think that's that confusing. So in main.c, no, in parse program, yes, this thing. What if we set it before? No, we still get the wrong binary operator program. So the binary operator of plus and 1. This is going very wrong. It's okay. So this function, our entire result, right? Our entire result means that our global context result will equal the current expression we are parsing. I don't think that's too insane. So then we should say, hey, that expression you're parsing, create a new one and parse into that. You see how that's confusing? So we should only do this if we need to continue parsing, which means or, not context parent, parent. Hey, look, I did it. So if we are returning into the global context, so a better way to say this might be like this. Returning into global context, complete return expression. Alrighty. I think that's correct. And I think, hopefully, that's all my time in the world. That I took more time than I actually should have, most likely. So, if not parent, not parent. Hey! Rohan says, we can set it equal to result 2. Ooh, Kappa. CyberPatty says, I'm cybersecurity guy. OPSEC top notch. Pogged. Rohan says, it's all confusing for me, but don't let that throw you off. CyberPatty says, thanks for your time. It was precious. Thank you so much. That's so sweet. I really appreciate that. Man, look at this. We're actually parsing some complex stuff. Yees. And we're doing some basic math in the code gen. Yeah, 2 times 3 plus 1. Still doing that. Pretty dope. Pretty dope. We need to variable accesses. Oh, that's right. We have that to do at the bottom. So next, we literally just have this to do. Local variable declaration. And we have to code gen local variable declarations. So when we also function calls, right? So next, we're probably working on code gen some more. That was so much fun today. Also, we should do the errors. CyberPatty says, sick assembly, Brit. Yeah, so every time we compile, this gets regenerated. This is actually the program. So this binary operators are currently code gen. So you see the plus, the errors. That's right. As if. You can see this plus of 2 times 3 and 1. So 2 times 3 is move 2 into racks, move 3 into R10, and then multiply racks into R10, 2 into 3. So then R10 contains 6. Then we move 1 into racks because we're no longer using it. Then we add 6 to 1 and use that as our answer. And adding 6 to 1 gets us 7. Look at us. Why R10? Great question. So let's see if, I think I'm gonna have to look this up. But if we will look this up together and look up the MS Windows calling convention for x64. So effectively, where is it? It's somewhere here. Volatility? Register volatility? No? Windows stuff, lol, I see. It's not Windows stuff. There's also ones for for Linux. I said Winix, Lamau. But we're code genning currently only for MS Win, x86 64. But if we look up Linux x64 calling convention, it's way simpler. Like it'll just show us, I'm pretty sure. Volatile registers, please. Volatile registers, please. No? Okay, Linux x volatile registers. So effectively, oh Christ. Yes, calling convention. Hey, here it is. So effectively, the calling convention in assembly, that's why R10 seemed random. I only know the Linux call conventions. Why would R10 seem random? There's no calls happening here, so there's no call convention being used. We're just listening to the volatility of the registers. So, for example, callee saved registers on Linux. Here it is. This is what I was looking for. This exact image is what I was looking for. I've seen this so much. So this image, you can see that preserved across function calls is no or yes. So if it's not preserved across function calls, that means you can just use it in any function, in any code, in any place, and not worry about returning it. It's still random. Most people are just boring using racks and RBX, but we can't use RBX. RBX is a callee saved register, and I don't want to generate code right now that saves registers as they're used, because that's complicated. RCX, DX, and SI and DI in Linux, along with R8 and R9, are all integer arguments, right? So we can't use any integer arguments because those may have arguments in them to the function that we're generating code within. We can't use the stack pointer or the base pointer. Those are both callee saved, so they must be saved, and they're used by the hardware. So what that leaves us with is R10, a temporary register, and R11, a temporary register, right? So across Windows and Linux, the only two well, the only three registers you can use are RAX, R10, and R11. Everything else is callee saved or floating point, obviously. Eternal Wild Fox says, I started writing a Lexer in C#. That's amazing. But yeah, so if you look at our code gen, we actually have this like register allocation system. So when we generate code for x86, 64, MS Windows for a program, then we create our three registers that we can use, RAX, R10, and R11. So if I put like BX in here, we could do it, right? And then the code that gets generated would use BX. But we can't use BX, that would be breaking things. We have to use R10. CyberPatty says, that makes sense. I should probably also use R10 more. Did I read that already? I don't even know. But yeah, it's a great register. We have 64 bits, 16 registers. Might as well use them. But yeah, this is very cool. Very, very cool. And yeah, we can assemble, link, and run and get the answer 7. We can do math. Hooray. We can do math. 2 times 3 plus 1. Does anybody know like something that would trip up a parser that doesn't use parentheses? 2 times 3 over 2 plus 1. That should be 4, right? We got 2. So 2 times 3. What got generated as the tree? I'm curious. So we have plus divide times. So 2 times 3 is 6. 6 over 2 is 3. 3 plus 1 is 4. But we get 2. What did I screw up here? CyberPatty says, in my languages, there is no difference between registers, so I don't care to change that, to be honest. So you're just not planning on any interoperability with the OS at all. That's fine. You don't have to. CyberPatty says, I change it if needed later. Should be trivial change. Should be. Nope. Nice. Yeah, if you don't plan on OS, F Windows, that has nothing to do with what we're talking about, but okay. I understand you feel that way. No need to reiterate, but... So you're never going to make syscalls to Linux, for example. Because the system calls to Linux use the calling convention, which means that you have to preserve the proper registers. He says, I am though. Well, then you should use the calling convention and use the proper registers. Otherwise, you're kind of just getting lucky with your assembly, right? Because there's a whole calling convention that the kernel, every part of the Linux kernel will expect that calling convention. I am using them, but just for syscalls. Oh lord. Okay, yeah, that's fine. That'll work. That'll work just fine. Because you'll be able to set up and prepare, and all values are popped from the stack. Ooh. Ooh. Okay, so I think this is working. We have done it. I'm not going to work anymore today, like Porth. Stack does not care about registers, Lamau. You're correct. So all you need to save are RSP and RBP, and you're like, anything else? Screw it. I don't need it. Which is pretty funny. But that totally works, to be fair. That totally works. So you could write some monstrous code generator. That would be amazing. You could like have quaternary operators and not worry about running out of allocated registers. That's so cool. Very cool. Very cool. Well, it's working. With that, I've spent 5 hours today sitting in one spot. So it is definitely time for me to do something else. I thank you, everybody, so much for watching. Look at this amazing AST we are generating from this amazing code on the left. It's beautiful, it's beautiful. We have this parsing context that we're able to parse, so we're now keeping track of our context as we go, which will allow us to, actually do variable lookup in CodeGen, which is what we were having trouble with, and we even put our to-do. CyberPatty says, thanks for the fun stream. Of course, CyberPatty. I will be back very soon. Tomorrow, if I can think of what to do and figure out how this local variable declaration works and what code I'm actually going to even try and write, which is likely. So tomorrow morning, I'll be back here. It may not be morning for you, but it's morning for me. Tomorrow morning, I'll be back here. And Rohan says, thank you for the stream. Thank you, Rohan. I really appreciate you watching, along with CyberPatty. In Eternal Wild Fox. Eternal Wild Fox said 2 + 2, but it has parentheses, which we don't parse yet, so that would be an issue. Eternal Wild Fox says, take care. Thank you, Eternal. I love you. I love all of you. Thank you so much for watching. We have completed it. We have worked more on our epic compiler, and we made some progress. It's not too bad. This context thing is pretty important. So yeah, hopefully this doesn't like kill my internet when I download the VOD, but epic compiler fourth club. Wait, it's not fourth, it's Torth. Wait, it's not Torth, it's Korth. Wait, it's not Korth, it's fuck. All right, I love you all. Thank you so much for watching. I will see you in the next stream. Be sure to check out that Discord down below for notifications when I go live. Gnarly Quack says, have a good one. CyberPatty's laughing. Good night, CyberPatty. I'll see you next time. But yeah, check out that Discord down below. You'll get notifications every time I go live. Thank you, CyberPatty, for joining. We got announcements every time I go live. We got friends. We all talk to each other. Ooh. And it's a lot of fun. So I really recommend joining the Discord. Be sure to check out that YouTube channel down below, or the Twitch channel if you're watching this on YouTube. And, check out my VODs. Check out if I'm live. Check out my previous broadcasts. I got all of it. It's all up. It's all on the internet. I code a lot. Watch it if you like it. In any case, this is now the time where I get down on my knees at the end of the stream and say, thank you so much. I spent 5 hours today coding and talking with you, and I really appreciate it that you would show up for it. In the future, it would make it easier to show up if I made a few dollars off of it, right? If this 5 hours wasn't just free time that I have to spend, if it actually became paid time, it would help a lot. So, if you would be so kind, be sure to check out that PayPal down below. If you leave a message with your donation, I will read it on stream, and if you leave your username with your donation and your message, I will read those on stream, so as long as it's appropriate. So, thank you. I'm done on my knees now. I've said all my ads, done all my things. We can now farewell on a positive note. Bye! Bye, Mom. Bye, Dad. Bye, family. Bye, God. Bye, dog. I was just dyslexic. I read it wrong. Anyway, bye!